Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello everyone and welcome to another episode of the WeAreDevelopers Live Days. My name is Benedict, I'm Community Manager here at WeAreDevelopers and I'm glad that you all joined us today. So today is all about Web3, but before we start with the talks, just quick heads up. Our regular viewers know it already, but we are back as an in-person event in Berlin because our World Congress takes place in July 27th. To get more information, go to worldcongress.dev and claim also your early bird tickets. And second, quick heads up, if you are based in or around Vienna, the Vienna Up is taking place next week, so check this out also. And now, before we start with the talks, also quick info for that. During the talks, feel free to interact in the chat to your right. If you got any questions, submit them via the big blue ask button. But as usual, please respect each other and be nice to each other as we have a code of conduct. Here's a short video about it. So, and right to the first speaker of the day. He is product owner DLT Mobility at the Robert Bosch Group, has a degree in computer science and business administration. He's interested in current IoT technologies, and with his over 30 years of experience in project management, he certainly knows what he's talking about. Welcome, Peter.
Hello, welcome.
Great Hello, Peter.
Have me here.
Yeah, thank you so much for joining. How are you?
Quite good. Feeling better again. Had a little illness last week. However, now it's okay.
So right in time for the live day.
Absolutely.
Perfect. All right, Peter, before we start, would you mind sharing with us what we are going to learn from you today?
Yeah, right. I think Web3 is one of the major disruptive technologies which come to us. And here we at Bosch really are looking to understand these developments and how these will influence our business models, our technology roadmaps, and so on. Because the old and classic industrial corporations are really not the fastest, as you all know, not as fast as startups or the smaller companies. So we have to do here a lot, and I work in a development and strategy project since 5 years on these topics. And I would like to give you a little bit status overview, what we are up to and what we have to see in the future here.
All right, sounds very interesting, Peter. And without further ado, I would say, stage is all yours.
Okay, thanks a lot. Welcome to everyone again. As I was introduced, I work really like 35 years in these topics as a computer scientist. Not especially in Web3 topics, however, I always looked into developments of the connected services of internets of things lately, and definitely here now in decentralization aspects. So as was said, since I'm a computer scientist with a background as well in economy, I have an MBA here. So I think this is a perfect setting to talk about distributed ledger technologies. What it is, maybe I can talk to you a little later. So I'm the global product owner at Bosch for these topics, and everything what has to do with decentralization topics in opposite to central platform topics, you will get a glimpse of, I guess, in my talk now. The title is Trust as the Key Concept in Future Mobility. So really it's all about trust in the future, because you never really know who is on the other side. when you are going online. That's what you all know. And it's more important to see what is happening if your car gets connected. If any of the connected systems in the future in smart cities and smart factories go online, you never know who is on the other side trying to connect to you. So trust, definitely in a trustless situation, is really mandatory here. So what we really see, and as I said before, I worked in a project since 5 years who is looking at the strategic implications of these decentralization aspects. So we started really with different topics here, give you an overview to that. However, to give you just now the status, what we are today is it's all about data these days. What we see is really from yesterday's experiences, closed ecosystems, identity silos, where when it comes to the person, to maybe companies, but as well to connected devices, where you see here the car, you always need to identify yourself, you always need to authenticate yourself. This comes from when you look at the person to the UX, of course. The user is interested to really understand the systems and he would like to have an easy access to the systems. However, corporates have another need. They need really to interchange data and as well do business with each other in a trusted manner. And when it comes to connected devices, this is not really yet understood what that means for the future when it comes to really identities. So that today's status, what you see here, and you always know the logos here in the middle, we have all these central intermediaries coming from Silicon Valley, coming more and more as well from the East, like China and other countries there. They give us as trust providers their data, their central platforms. However, it has a cost that we all lose our sovereignty in data. And this is really a huge problem in the future when more and more of these systems get connected. And where we have to go in the future is really a more data sovereignty, a more self-sovereign identity scenario. So we really need to get back the user, the corporation, or maybe as well the things that they get control back over their data. Because what we really see is that the central platforms take our data, take our interaction. We get a lot back, of course, yeah, because a lot of stuff is still free in the internet. But as you all know, if something in the internet is free, you are the product. And we need to change that in the future when it comes to more and more autonomous systems, more and more connected devices, corporations, and persons. And so what we are looking at, especially here, definitely is in terms of the EU regulation, in terms of the different business units, business areas, industrial areas, and products. What we see, we need to focus here definitely on these huge corporations and have some kind of an alternative concept to go more into the decentralized aspects of identity, of trust, of data exchange, and the like. So just this as an overview, and then I can really show you a little bit what that means, because when we come from a corporation, what they talk about is, okay, what kind of business model is behind that? Why should I do that? And just a very short glimpse on the developments, what we see when we call it Web 1, 2, and 3. That's why we call it Web 3 these days. But again, there are a lot of different definitions of Web 3 these days, so don't take this for granted. This is our personal view here. So when it comes to really Web 3 and what you see here with coming up of cryptocurrencies and really the interconnectivity of a lot of different parties, we see a lot of value coming into these different areas. And just a few numbers, a lot of jobs will come up in these new areas of decentralization aspects, and a lot of new interesting markets are coming up. Yeah, so the traditional players here have to really react quite quickly now to really go into these areas. You all know the hype words these days, cryptocurrencies, Bitcoin, blockchains, NFTs, metaverse, and all that stuff. So this is all somehow interconnected, and the traditional players do not really know yet what to do with it and how to earn money with it in the future. Is it important for us, or should we let all the other big players do the rest? Yeah, like Google, Amazon, Meta, and the like. But this is not really our view. We have to do something more. So the project I talked about really is looked at decentralized systems all the years. So we started here in looking at, okay, what is blockchain really and what are decentralized systems? And when I talk about blockchain, this is really not only one instance of decentralized systems. So because the best known, I would say. However, if we go really onto the end of this roadmap, what you see here, we really came to a status at a moment where we see we have to do a lot of with communities, with consortia, with the governments, and as well more and more with the corporations to really understand what is happening. And so, as you see, that the classic development here is getting focused more and more on decentralized digital identity. And later on, you might ask yourself, okay, what has that to do really in terms of software development? We'll come to that later. And really, when I say really something about corporations, communities, and consortia, there's one interesting new development coming up, because what Bosch just recently did was we founded a foundation together with one of the startups in that field, coming up together with some of the projects we are doing as public fundedly project, trying to really focus on with the industry. And in this foundation, for example, we are talking at the moment with huge other corporations joining this foundation together with us to really understand what's happening out there in terms of these technologies which are coming up, like artificial intelligence connected to decentralized systems, agent technologies, and the like. So lots of interesting new hype words. However, you get a glimpse what that does it mean later. And the main words and the main statements, what I always say is, we need to talk about decentralization, that always look on central platforms and always collecting all the data on one platform, do this in a more decentralized way. We talk about who can change what on the databases out there. So with decentralized systems, we have, of course, another concept where immutability is a huge key concept, that nothing can be changed later on, which has very interesting effects. So as well for hackers or for as well a cyber defense, this is a huge thing that we need to be more secure when it comes to cybersecurity. And as I said, trustless exchange in a zero trust environment, where you can't expect trust out there if you do not have trust as a service from one of these big central intermediaries. And they do, of course, their business model with your data then. And this leads definitely to new interesting product roadmaps, where we need a lot of new people who are developing that stuff as well for us, because we are leaving the classic development areas here. When it comes to front and back end development, we go more and more in terms of that is a classic basic requirement. But here, when it comes to digital currency, when it comes to digital notary identity stuff, you have lots of other requirements how to develop such systems. And the architecture looks really, really different here. And when it comes to smart contracts, where I have an interesting example later, this is a completely new way how to develop that stuff in the future. And for one interesting example, talk about economic devices. So that's why our project was called Economy of Things. We are talking here really about connected devices, which in a correct and zero trust environment, having this technology, doing the data exchanges without trust. So we are talking about the e-mobility future, where you have to be able to charge your car anywhere, in any place. And why not having business models in the future where you have your own private solar panels, for example, on your roof, and you can sell that energy to any car which needs that car around you? Or the cars can charge can charge and recharge or decharge again their cars, and stabilize the smart grid, for example, when it comes to crisis situation in the future. And therefore, you need really decentralized systems. How we think that is, I come to that later as well. But this is really one interesting example. When you go all these steps, talking about how do we digitally pay, how do we prove that we are who we say we are in a non-trusted environment, and how can we prove really our identity and do that in a programmatic way with smart contracts. So this was maybe more or less the scope of what we were looking in the last 5 years, and are now really in a status where we say, okay, now it gets to a more concrete way. And talking about doing business, definitely, what do we need for that in the future when we talk about highly connected systems? So what are smart contracts? Smart contracts are more or less really whether no contracts nor are they smart enough. However, this was really this expression. What we need to do really in traditional contracts is, okay, we have these parties coming together, they make this contract together, and they need a third party who is able for trusting that stuff. So anyone, if you pay with PayPal, if you pay with any other of the systems, credit cards, we need always this third party who can prove, okay, this is really that the payment is going there and the parties are known, and so on and so on. So the execution and the bank stuff is all quite centralized and all right manually still in the digital world, which leads to huge problems when we have a highly connected system. When you talk about smart contracts on the other side, we have again the same parties, however, new parties maybe, because now we are as well talking about devices and machines talking to each other and not only exchanging data, maybe have as well to have to exchange values, like doing business with each other. So this is there we have a completely new requirement with smart contracts, because smart contracts are in a way a decentralized way of letting machines doing business with each other in a programmatic way. So we have, it seems, a kind of digital trust automated by the network. So we have some kind of a consent technology, which makes sure that these parties are really enabled to do the business and are really in a legal way, because that's where the term contract, a smart contract, comes from. They can, in an automated way, execute their business with a software. This makes it very interesting. And you can, again, think about that. That makes it a completely new way how to make the business and how to develop the systems that you need for that. So if you go further that road, what we mean with smart contracts and how they get really implemented. So this is really a further development of the classic software development systems, where we see, okay, Solidity, here's one example of a smart contract language. This is running on a Ethereum virtual machine, more to that later. And if we talk about these programs, we talk just about classes, like these templates where you initiate objects out of this and create really two different instances talking each other. However, these are really, when it comes to the smart contracts on Ethereum, Ethereum is one of these blockchains which are really quite common these days. And they are not really on one place, so you do not talk to one server when it comes to the other contact. You have this spread over the world in hundreds of thousands different nodes who, as I said before, have this special technical consensus algorithm behind. So it makes sure that everyone exactly knows who is talking with whom, who is able to exchange data, values, and the like. So really, we have these different accounts there. Like, think about your bank account where you, if you want to buy something, then you have to contact your bank. They say, okay, your account have enough money, and then you are elicited to really do that sale, or you can buy something. Here in that case, we have an automatic approach. When we call about Solidity here in this specific example. So here's a very, very easy way how to program a getter and a setter in a way of how Solidity would do that, in a very, very primitive way, of course. So you have this, we have always contracts, which are these class definitions, and you have to define some kind of data types. And then we can set up or define functions which set data, have this really part on the blockchain on some kind of specific decentralized way, and then you can read that data again. So a very, very easy way how to understand that. But now the interesting part comes, because there is one peer who wants to do a business with another peer. So this peer can really be a machine, can be a person, can be a corporation who would like to talk to other decentralized parties. And this, of course, gets provided by this one peer, has to develop that program, that smart contract. This then gets deployed as bytecode on this virtual machine from Ethereum. So this is a very interesting process, what's happening here. This gets now really copied and synchronized all over the world in all the nodes of Ethereum. This is really hard to grasp at the beginning if you have never heard that. However, this is really, so we have a world computer existing here. So it is really consisting of hundreds of thousands of different nodes who have now these specific bytecodes in one of the blocks in the blockchain. And this gets executed, and the other peer then, where the business is done with, can then or learns about that contract, about the possibility to get values, to be able to buy stuff. However, in a way that is immutable, because that's one of the things it can't change, and it can't as well get hacked or get changed anyhow. So these are the main I would say, requirements of a blockchain, that you can't change it afterwards. However, we have an unspoken coordination here. We have a technical consensus algorithms who makes sure that this peer is really well known. He has really an account, that this peer as well is known because it's somehow on a state on a blockchain or based on a blockchain, has money really to buy stuff from him. And through these contracts, they can make sure that that business takes place. And so really to understand this, we have a huge decentralized database. And this is because why it's so important that we have a decentralization aspect here with accounts on it, where different peers can then do business with each other. And they can execute machine code on this huge world computer and be sure that nobody can change that or can hack that. And if this is really done in a correct way, of course, you always have the human factor behind it. But technically, if you do it right, it's not possible to get hacked and to be spoofed or anything like that. So this is the huge power of the decentralization of smart contracts in the background. You might have heard, of course, in the press in the last weeks, months, and years, that all the time there is some huge scandal because some of these decentralized exchanges happening. However, these were always done because of criminal aspects of some of these developers behind that. So it was not really done quite well. In this way here, when we talk about Ethereum smart contracts, for example, we have a huge industry as well who are validating and verifying these contracts before they get into place. So you can do that really quite good without having the danger of getting hacked or done any misuse with it. So why do we do that? Again, coming back to the trust issue, when we talk about different industry sectors, we always have highly connected systems, as I said before. And a specific technology we're looking at the moment is self-sovereign identity, which is based on some kind of decentralized systems, not necessarily blockchain. However, you can use that. And in all the different business industry sectors, like building technologies, finance, of course, banking do that a lot these days, IoT, Internet of Things, power tools, as we have one, like the drilling machines, like all the other machines that we as well have, and mobility, for example, where I'm responsible for, and e-health, for example. These all are areas where you need to have a means of a way to connect to each other, to exchange data and values and all that stuff. And especially in the case of identity, you have some specific kinds of wallets that you have to have wallets, like your classic wallet that you carry your money with you, or in an electronic digital way, you have to have something like an e-wallet, an electronic wallet in your car, on your mobile phone, in your any other device that you are using, which is connected somehow in a smart city, in a smart factory, and they are all interconnected. And need to do now really get connected and do that business with each other, identify themselves, authenticate themselves. If you would like to charge your car, if you would like to park your car, and so on and so on. Therefore, you need this kind of wallets, and you need a means of connecting again these three different areas: the people on a really user-based area, the things, the cars, the charging poles, the traffic lights, and you can think of any connected device in the future, and of course the organization who are behind that business, who own the fleets, who own the buildings, who own the services which you can acquire in a smart city, for example. And therefore, we had a specific system which is really defined by SSI, where a lot of industries, a lot of governments are looking into at the moment. You always need an issuer who gets out some kind of a identity proof. You need to have a verifier on the other side, which is the business who would like to make business with you, offers you a service. And of course, the holder, it's you, it's the car, it's the building, who has this identity given out by the issuer. But the interesting thing now is, if you go into a business relationship with the verifier, with some business, with some shop, or maybe with the charging pole, then they can prove under only from a peer-to-peer approach that you are really authenticated. Do you have this correct identity without getting back to the issuer, to like a bank or to like the government agency or anything else? So because they can get trusted, they have their they trusted anchor again in some kind of a decentralized system, which as well is proven or is identified and verified by the issuer on the other side. So without going into detail here, we have really a secure system of proving that the identity in a digital and decentralized way is taking place without trusting central intermediaries behind. Because of course, these days you can have this already with Google, Apple Pay, and all the like. However, you always have this huge organization in the background who always can increase their prices, maybe can get hacked because they are central, and have other maybe like criminal misuse happening inside the organization, anything like that. Or think about cybersecurity stuff, cyber criminality, and all that, which is happening place. And in decentralized system, this is really, really hard to do. However, we have to look at that as well. And security is a huge concern for us as well. So what we are looking at really in detail is definitely the main things in mobility. What is very important when we talk really to the car manufacturers is the e-mobility of the future. Charging poles, we need to really be get in contact with them. The parking places in smart cities or other parking concepts with fleets, with shared car economy and so on. It's very interesting if this comes in an autonomous way, because in the future, you might have heard that they try to let the cars drive autonomously. I say try because this is a hard way to go still. However, it will come. And when it comes to traffic systems, you have to have zoning in smart cities where you always you have to prove that your car is allowed to go into the city limits and so on and so on and so on. And of course, we have to talk about smart traffic systems when you have autonomous automatic cars who really need to be sure, is there on the next corner really no car coming, and can I go over that crossing and so on. Therefore, really, we need that the different Web3 technologies when we would like to do this in a decentralized way with all the set advantages that we see here in the future. There are really agents, very important topics, because you need to have smart parts, smart little software elements somewhere out distributed on these decentralized systems, helping you talking to each other, mapping as well, holding smart contracts together with smart contracts, letting them identify themselves, letting them make business and so on. Having these e-wallets really on these different devices. And as you can now imagine, for that, we really need these huge systems working for us, not against us. Because when we talk about more, you can get this already today with the huge corporations. However, you always have to trust them, and trust really in not zero trust environment is quite hard, as I said before, but I can't repeat it too much. And together with that's interestingly to talk about this today here, together with our international offices worldwide, and especially here with Vienna office, for example, from Bosch, we are building such kind of ecosystem demonstrators where we really find out, okay, how is this all working? What kind of software and hardware systems do we need for that? Because we have always these central topics here, driving, parking, charging for the mobility use cases. There you have to have different aspects. You have to have decentralized marketplaces where you can find and get offers for different services in the city. You have to have a means of how to deal with data, which is not mine, or which is mine. I don't want to give it out, and I would like to have the sovereignty of the data myself. And when it comes again to these SSI aspects, to identify who you are and can you really pay for that service and so on, and the smart contract and stuff. And you can see this is a huge system where we try to really implement it already now, because current studies say that still the Web3 technologies will come. However, we need to be very sure what to develop here. Where does it make sense? Because, of course, a lot of decentralized systems are just more comfortable, are just more easy to use and stuff, and this will be there and still be there. However, we do not really work against all these cloud mechanisms or decentralized systems. However, in some specific systems, what I said to you, we need to be prepared. And then again, what are now the building blocks in the technology sense? Okay, blockchain can be one. Blockchain really is a huge expression of decentralized systems. And as well, then we have to connect to the classic world, to the classic database out there, and that's where we need data oracles. This is more or less really these interface parts when we really need to connect the decentralized systems where all the data of the world is stored at the moment, definitely, and gets still stored in the next years too, which is what we need to have an interconnection between the decentralized and decentralized systems, and that's where data oracle come into place. And what I said before, we see in agents a huge concept that helps us really to manage really these relations between machines, corporations, persons, to really have this all going when they would like to exchange data, values, and so on. And therefore, you need some kind of a smarter instance if you are not the part who is taking action, but you're always starting it, and something needs to get autonomously. And so when we come now to a very interesting another building block here, you all have heard, of course, the NFT hype, which went through the press the last years. However, this is nothing more than a specific case of a smart contract when you look into the technical background of it. But the NFT part is really very interesting because here you have a thing of tagging some value to digital aspects or items like artists' work, because what was very important or very interesting in the press were all the monkey pictures and really other very interesting images, artwork, which have this NFT requirement behind it. However, the technical aspect is quite more interesting because, again, these are mostly Solidity smart contracts in the background, which help you to put some identity mark, to put some proven authentication certificate behind some asset that you can handle or deal with it. This is the very interesting part. And then you can talk about or think about NFTs really to prove that this data belongs to you in your car, for example, that this identity, what you have, you can use for proving to others, okay, I'm really the owner, and this is more or less what NFTs are doing. So really making sure in a decentralized way that you are the owner of the specific digital asset. And so there is, my message here is there's much more behind the NFT, what you normally get out of the press. Yeah, so it really makes sense to look a little bit in the background, because if you go on the different marketplaces for NFTs, you always have the possibilities to look into the contract sources for these NFTs. And then you see Solidity smart contracts in a quite easy way normally, that you really see, okay, what happens really behind it. Because the one good thing is it's all open source. You can always go into the code and look what's really happening. If you buy one of these NFTs, what can you do with it later on and so on. Because we have classic JSON formats behind that. We have classic metadata algorithms or architectures behind that. So this is really not rocket science, really. But you can dive into that. But it's not too easy, and it's quite a disruptive way in using it in a decentralized way, of course. So, but one thing you need to know as well, and that's what is very important to understand. When we had this picture before, where we have all these connected devices and people, you have this kind of wallets, where you always have such kind in a public key manner, that you have your private key stored somewhere where nobody can access this, because this is your proof that who you are and your real money basis. And then you have these public keys, which everybody outside should know, that you can connect and prove who you are. So we have these different areas. So we have the hot wallets and the cold wallets. So what are these? The hot wallets really are what you definitely see today when you go to the internet and you go to these websites, can buy cryptocurrencies and do other stuff in the decentralized world. Then you have these hot wallets normally. And then you have on the other side the cold wallets, which are non-custodial. On this side, you have not really control over it. On that side, on the non-custodial side, you have the control, because in a cold wallet sense, you have your keys, as I said before, these private keys, not somewhere in the internet. You have this here directly in specific devices, like a hardware wallet. Or you can have this in a paper form. You can write down these letters that you normally get out of it, and you have brain wallets where you can remember that stuff. However, you have the control over this. And these private keys really are own you, because this is one of the major important sayings here, definitely. If you do not own the keys, you do not own the money. Yeah, not your keys, not your coins. If anything is happening on the website with these wallets, get hacked, and so your money is gone. If you have own control on your devices, then you control it. And this is the basis as well, what we're talking in the industrial sense. If you have such a wallet in a car, then you can have control over your data, over your authority, your authentication processes and all that, and your identity, which is most importantly. And then you have the control, and not any other central system, again, which can be hacked, which can be misused, which can be used as well for their business models and not yours. So this is really the other very interesting example that you need to understand. And of course, they are all talking about the metaverse. We as well are talking to it, because this is one of the very interesting development when it comes to Web3. But it's as well nothing really specific in a completely new way. What we are using here is really all these decentralized technologies that we are used to, which are getting related to that. However, of course, you have these nice virtual reality parts of the metaverse. This makes absolutely sense as well in industrial matter, because if you can use the metaverse aspects in a decentralized way, so you really can be sure that you are using these technologies when it comes, maybe for as an example, digital twins, that you always know who is on the other side and who is really that stuff built in a digital way. And you can go into the machine really and see what's happening there with a virtual reality set, for example. But there, again, if it's on the other side of the globe, you have to be quite sure that this is with the real data that you get here, and that you really can as well, if you need to pay for that service, for example, can be sure that this happens in a trusted way. So again, when it comes to this thing, metaverse as well will come. I'm not quite sure in which way. However, this is a very important thing we have to look as well. And again, the main building blocks here, again, as well, are all these parts I already talked about, and much more, of course. And when it comes, everybody talks about these days, ChatGPT and stuff. This as well is just another component. We need to be quite sure that this happens in the future as well in decentralized way. Because think about, where does that data come, yeah, that ChatGPT is learning from. It's not really sure who owns that data, and who really, what the further developments will be here. So again, you need to have proofs who gives their data for this learning language model, what ChatGPT is using or other stuff is using, and who is really able and legally possible to use it. And again, these cryptocurrencies, the decentralized identities, are all these building blocks which you maybe need to use in the future, really, when it comes to Web3 elements. And just to give you again the idea, what you as developers need to maybe learn in the future is really to build upon your knowledge, your competences that you have today in a decentralized way. So what do I have to learn now when it comes to really wallets? What do I have to know when it comes to security issues in the public key elements, when it comes to cryptocurrencies, how they're built, when it comes to smart contracting and how they get used by NFTs, by digital identities, by agent technologies which are decentralized, and so on. So this all is connected to each other. A huge plethora, of course, of new learning fields that you can go into. However, as we see in very, very major studies, more and more or less this will come, and anybody in 5 or 10 years who has not the competencies here in that field which will get left over, because this is the major development which will come. Okay, why are we looking really so deep into these areas? As I said in the beginning, we see it really as the future killer use cases, not only for Bosch, but really as for all the industries out there. And I think the huge software corporations have already understood this, and they are doing a lot in the background here. And they, of course, have the fear that their nice centralized business models can get somehow eroded by that, because, of course, if you do it decentralized and own yourself with your own data, then they lose, of course, their business models. So if you look here in terms of energy building technology, what we are looking at the moment, really, as I said it before, all these interesting energy trading business models that we see is very interesting. And you see here lots of interesting other companies who are already in this area where we are talking to, and where we are in a corporate or community effort are working together. When it comes to industrial technology, of course, said before, the VR or augmented reality based technologies are very, very interesting and get very, very in relation to these Web3 technologies, very, very important, and lead to very new fields of application. When it comes to asset tokenization, a very interesting other broad field, how to digital pay for stuff which is out there, which can have a value and can get dealt with. And the machine-to-machine communication is really a huge place when it comes to Industry 4.0 or 5 or 6.0, what will come in the future. There you as well need to have these decentralized systems again on the other side, and not only centralized systems. When it comes to the other side, to the consumer goods, of course, which is when it comes to the end user, which is very interesting. So here again, we have to understand quite good what's in these NFT marketplaces for the industrial side. What does gaming mean to the classic industry? Because when it comes to gamification, when it comes to the hybrid systems of doing stuff right in traffic, in other industrial systems, you have already today some gamification aspects. And I see there is some kind of a hybridization, some kind of a melting of these different technologies, where you can really distinct between where ends gaming, where starts real industrial play or industrial work. So this gets really interesting in development here. However, this needs to get trusted in a not a zero trust environment. Again, decentralization is king here. And all the other stuff that comes around, I talked about a mobility solution already. However, this is one of the major fields that we see as well, definitely coming up in the traffic, the future. And now one tip I would like to give you, one hint. You definitely need to go to that page if you want to learn more about these decentralized technologies. For example, the classic blockchain basis, what is there. And this side I always really try to talk to the people, go there, because you really have the possibility to learn more about, okay, what is now a decentralized system? How do we use here hashes? How do we use public key technologies? What is a block? What is a blockchain? How get distribution done? What are tokens, Coinbase, and all this stuff? The nice thing about that system, really, you can learn a lot. You can try it out. When you go to the page, you see videos explaining all that. And of course, you have the online tools playing around with it and really get a very good glimpse of how it is. And the best thing for us developers, definitely, you can fork the whole thing on GitHub and do your own experimentation with it and get really a glimpse of how does this work in the background with classic development schemes. However, what do I have to learn in a new way when it comes to decentralization? And this is really a huge step forward that we can, if you are interested, learn more about Web3 basic technologies, starting maybe with blockchains, but going much, much deeper in the whole technology here as well. Okay, that I think was a really short overview of all these very, very interesting disruptive new technologies which we are seeing and what we have to do for that. I guess we have a few minutes as well for questions.
Hello, Peter. Hello again. Thank you so much for the awesome talk. And yeah, you guessed right. We have some minutes left for a Q&A, and I would say let's jump right into it. So first question. Hello, Mr. Peter Busch. I'm Volcano from Greece. Do you think that smart contracts will have any disadvantages for us? If yes, what are these? And can we do something to solve these problems?
Yeah, definitely. Anytime if humans are creating something, you always have the risk of doing it not in the proper way. So smart contracts on the one side, if you of course have not really the best programming or algorithmics behind it, then the huge risk there is that these are, because they are immutable, make a huge danger, huge damage to financial systems, to technical systems. So if they are not implemented completely or correctly, then they definitely have a huge risk because they are autonomously, they are really out there, and you can't normally change them again. However, there are ways, of course, to get rid of them again. But once they are out there, and there were some examples in the past where they lost really like millions of euros and dollars because the smart contracts were not correctly implemented. On the other side, if it's not only the algorithmics part, of course, these are autonomous systems, and we as human beings has always looked behind it to what does that really mean for our systems, how to interact, how to communicate. So there we definitely have huge work to do still, how to use these smart contracts in autonomous systems, and really how they need to get interacted and what kind of control we need to still have as human beings.
Thanks for that answer, Peter. We got some more questions. How do you see trust evolving as a key concept in future mobility over the next decade?
Yeah, as I said before, I think the main basis here is a means of having the digital identity that we can control ourselves. So when it comes to really trust, you have to trust the systems out there. And therefore, you need to have a technical system helping you with that. And so one thing that is very interesting is that more and more governments are looking into that as well. So the current development here with the EU, for example, is that they are demanding some kind of an EU wallet, which then gives you the basic requirement to have some kind of a digital identity for your systems, for your personal documents, for health systems and all that, which are based on decentralized systems. This is the very important thing, that the governments have understood it, that we can't let the Apples, Googles of the world, or maybe the Samsungs or Hyundai, or call them from the eastern part, control our identity. And this is really the most interesting development these days, where we have to look in how to get rid a little bit of the uncontrolled use of our data. And therefore, we need such a decentralized systems, and therefore we get trust in a decentralized way.
Right. Yeah, totally makes sense. Giving these identities to like the corporate is the first step to the dark future of cyberpunk, as we all know.
Exactly.
So, Peter, thank you for that answer. We got another question. Are there also risks or concerns with implementing a decentralized automotive ecosystem?
Definitely. As I said before, there are always the risks if a technology is not implemented correctly. That's always with any system. And we always have to make sure, and this is why we really as well founded the foundation, that we have a very, very good and working governance behind it. That you always be able to change it again, to have always the control as a human being, work together, of course, with corporations, with governments, with the end user, to really minimize the risks which are there. You never can really get rid of all the risks in the systems, especially when they are autonomous. And we always see this topic things when it comes to a huge autonomous system where you do not have the control anymore. And therefore, governance and the rules behind it, the human factor is a huge, very important part.
Yeah, makes sense also. Thanks for that also, Peter. Next questions. How do decentralized digital identities enhance data privacy and secure in all of the connected vehicles?
Yeah, the main technical concept behind it is I try to explain it a little bit. is the some kind of a public key infrastructure behind it. So really, privacy only makes sense and can happen if you as an end user have complete control over your data. And you can really decide who gets what data from you and what data is not to be shared. So there is some very interesting concepts out there, which is called zero knowledge proof, which means that you can buy services or consume services where you have to authenticate yourself, but not giving all your data out. So for some services, it's only very important that you have to be over 18, for example, maybe that you have a license to drive, that you have something like that. But they don't have to know where you live, what your social security number is, what your health status is, and all that other stuff. In today's systems, what you see is when you have a user account somewhere and you have other connected user accounts, on the other side, they know everything about you. So privacy is not anymore possible, but in the new connected decentralized system, what we see here, it's important that you can consume the services, do not have all the time new user accounts, give all your credit card data, all your other data into the systems, but really only that tiny data, what is really needed. And this is really then coming to a privacy as we imagine it for the end user in a sovereign system.
Okay, so you can adapt your private key to only give out the informations, even though the public key requested lots more. And
exactly.
Okay.
So you have to get, of course, in a relationship with the other party. Yeah, you would like to consume the data, definitely, but you can control as a user what kind of data you would like to give there. Yeah, and who really is able to use it, and really make sure that other companies can't take place there with your data or can't make their own business. As you all know, yeah, what cookies do in your computers, what all the other technologies are doing, they are using really your interactions to make their business. And this should be really minimized in the future when you have much more connectivities or more connections which you need to use. And with this public keys scheme, somehow, and with decentralized schemes, I think this is the correct way. Not perfect yet, of course, we have to develop this even further, but I think this is the right direction.
Right, thank you, Peter. I was just waiting for it, and here it comes, the IA question. How big is the role of AI in the development of future mobility technologies? If yes, what AI are used?
It's huge, definitely. So yeah, what we see these days definitely is in all the areas where AI is really coming. However, I think the major point, what I stated before already, is we need to be able to control what is happening with AI. And this is, of course, already quite difficult, yeah, because all the systems are enabled already with that. However, AI is nothing more, I would say in a very simplified way, using the data which is already out there, making its own concepts out of it, learnings out of it, and so on. And this is one of the reasons we as well founded the foundation with a company who is trying to combine AI, decentralization, and agent technologies to really overcome the risks that we see here. So you have AI in all the components of the future. This is as well as sure as electromobility will come, as cyber security risk will come, and all that stuff. However, you need to be able to control it. And one way is having AI controlled by decentralized systems, where you as well have to control what kind of data is used by that AI, who is able to generate these models. And we are talking a lot about collaborative learning models these days, where you see, okay, a lot of parties coming together, share their data to build up these new models, these new AI models, which then can be used by the systems. But it may have to be made sure who owns that data which goes into the systems, and what really is then possible to control, or how to control that system. And there again, you need to have the identity problem solved, you need to have the centralization challenges solved, and so on. So here we see a perfect combination of decentralization, agent technologies, and smart contract technologies, and AI. Yeah, so this is it makes it not very easier, It makes it much more complexer. However, when we talk about it and you see the major speakers out there who have all the fear now that AI takes over the world and stuff, we can definitely hinder it from doing it too fast.
Good. Awesome. Thank you, Peter. I would say let's take a step back from all these technical questions and talk a bit about you, your job, your role. We know that you have 2 degrees from university and you have over 30 years of experience in project management. Maybe you want to elaborate a bit more on that, like how you started your professional work and how you ended up where you are now at the Bosch Group.
All right, yeah. As I said, like 35 years in business at the moment. I started out as a, today you would say, a CEO or co-founder of a startup. I started with an own software company, like back in the 80s, and developed software, database software, dealing with some kind of automated or traffic systems to give out tickets, to give out all the other stuff and so on. So I had a small software company with 2 other people together. And then, so I was again the own developer here. And later on, then I saw that maybe not the best future for me, because I had always this stuff with, okay, invoices are coming not in, and much troubles with all these other systems and all that stuff. And so, yeah, I decided then to go into the corporate world and started in banking as a computer scientist with this MBA. It was as well a perfect thing. I worked in Frankfurt with a huge investment company there, JP Morgan, and was there responsible for the technical broker systems. So getting the data from the London, New York stock exchanges, let the traders do their job. A huge interesting area, because I saw monitors flying around, yeah, when the business was really winding down and so and the stuff. But I had the luck, I was always on the technical side here. And then later on, I went to Sun Microsystems, because these were the main systems we were using at the bank, and went there more or less in the software hardware development, and went there a little bit more as well in project management and helping banking and insurance companies using these systems. And then later on, when the internet bubble burst, so I really watched all the time the development of the internet, then as well the internet bubble coming up, and then as well development of the other interesting systems. And when the internet bubble burst, Sun Microsystems was sold to Oracle. And that was not really my company I would have liked to work for. And that was the reason I changed to Bosch. And then like 17, 18 years now, I was then working for Bosch in different places. I started in corporate research, really doing a lot of that stuff in terms of, okay, what is the internet? How is the Internet of Things changing the company? And was there responsible for all these connected services? And then, of course, the development took place to where I'm today, looking over the interesting disruptive new technologies which are coming into the company, and helping projects in the business units and our strategy units to really try to foresee what is coming and how do we have to develop our roadmaps for that.
Wow, what a journey, Peter. And your time in Frankfurt sounds a bit like the Wolf of Wall Street with like the flying monitors and everything.
Absolutely.
So it's all true. It's all true what we see in the movies.
I can connect to that, definitely.
Like the new Jordan Belfort. Peter, since you're a product owner, maybe let's talk a bit also about your team. And do you maybe have currently some open positions also in your team that you can talk about?
What I can say as a product owner, really, I have the responsibility definitely for the architectures, for the project developments in terms of software and hardware products. And we are in a huge transition at the moment, because what we see really, electromobility is changing all the companies when it comes to autonomous driving, which will as well change, again, other parts of the company. And as you say, crisis all around us at the moment. And this is really something which as well is not the best situation at the moment for really new jobs at the moment, unfortunately. However, I see a development going upwards again, really in the next year. So currently, we are really keeping the the work with the people that we have. Happy to not losing people, yeah, definitely. However, on the other side, we are looking forward definitely in the next, I would say, month, yeah, if we get over these crises which are around us. I think in 24 it will start again, that we again have new positions then, because as I said before, a huge interesting future is before us. And so we have a few more years to overcome. And therefore, definitely, we need people. So my hint here, definitely, look into these Web3 developments, look, of course, in AI developments, and then open positions will come again, definitely.
Very valuable tip right there for the audience. Peter, thank you so much for the amazing talk. Was awesome to have you today, and looking forward to your next talk on another live day, maybe.
Thank you very much. Was a great.
Until then, nice rest of the day, Peter, and see
nice
you soon.
Thank you, and talk to you later. Bye then.
Bye, Peter. All right, and before we jump to the second speaker of the day, just 20-second break.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
And now, right back to Web3 and the next speaker of the day. He is CEO at WeAreDevelopers, spent the last years diving deeper into blockchain, and founded even a company together with his friends. Welcome, Marko.
Hey, hello, Benedict. Glad to be here.
Yeah, hello, Marko. Awesome to have you today. Hope you're doing fine.
Yeah, doing great, actually. I'm here in Split at a conference called Block Split. Yesterday we had a pitch, so I'm still under the impression. So everything's good.
Nice. And after the Congress, you can dive right into the ocean.
Yeah, true.
Awesome. Okay, Marko, before we start, maybe you want to give us some insights on what we are going to learn from you today.
Oh yeah, sure, definitely. So today I prepared for you a short introduction to Web3. If you are a developer or you want to become a Web3 developer, I'm going to give you a brief overview on what tools are you going to use when you deploy smart contracts. Let's say we are going to base on Solidity, so EVM, Ethereum blockchain, and basically explain some details about blockchain, like transactions, like blocks, and yeah.
Awesome, Marko. You got my full attention, and I would say, without further ado, stage is all yours.
Oh, thank you, Benedict. Okay, so first, I would like to go through this presentation to give you a short introduction on how everything is working and some theory about blockchain. So let's start by with some basic concepts. So let's explain what is a transaction. Transaction is the main building block of blockchain. Like every block has some amount or none of transactions in it. Every transaction has its own fields, like transaction hash, like status. So was it validated? Is it still pending? In what block is it included? What is the timestamp? So when was it validated? Sponsored, we don't have to deal with this because this is a fairly new feature. Who sent it, right? To who? So who was the recipient? And if you can see, here we have an address in OX format, and here we have something different. So this is called an ENS. This is Ethereum Name Service. This is something like I would say DNS. So basically, this name actually it actually maps to a address, to a format like this one. The value that was sent. So what was the amount sent with this transaction? What was the fee? So how much did we pay the miner to actually execute our transaction? And what was the gas price? So every time when we send a transaction, we need to pay some fee for it to be executed. And this fee is measured in gas. And actually, every operation, as we are going to see in Solidity, has additional amount of gas assigned to it. And this gas price, it actually oscillates. This is a price for 1 unit of gas. And if we put a price that is higher here, our transaction is gonna actually execute quicker, because miners or validators are gonna prioritize it. And okay, basically those are the key elements of transaction. And as I said already, every transaction goes to a certain block. These are also the fields of blocks. So every block has its number, or as it says, height here. It also has its status. It has timestamp, also as transaction. When it was proposed, so when it was, you can say, found. How many transactions does it include? How many withdrawals were here? So this is also a new feature because Ethereum recently went from proof of work to proof of stake. And with the newest upgrade, validators can withdraw their ETH. So basically, if you wanted to become a validator, you needed to stake like 32 ETH. And that is a lot. And you basically couldn't pull it out until recently. And every time validator pulls out some of that staked ETH, it counts as a withdrawal. And here we have actually 16 of those in this block. Then the guy who actually validated the block, this is also the ENS format, so it maps to an address. It says Flashbox Builder. How much ETH did they get in reward? What was the total difficulty, or how hard it was to validate this block? What was the size of transactions in this block? How much gas was used? So as I've said already, every transaction costs gas, and there is only some amount of that gas that can be fit inside of a block. So every block in Ethereum is limited with 30 million of gas. So that means you can put as much transactions in it to fill up those 30 million. And we can see that it was filled more than a half. So more than 18 million was filled. So also with an upgrade, Ethereum became a deflationary currency. And every time when a block is, every time when a transaction is, when you pay gas for transaction execution, some amount of that fee is burnt. And here we can see the accumulated burnt fees of all of the transactions inside of this block. And we also have extra data, but we don't have to worry about this. And by the way, all of these screenshots, like from transaction and from block, they are taken from Etherscan. So Etherscan is a block explorer. Let me in fact show it to you. How does it work? So Etherscan, you can go to this site. Okay, this is because I'm using VPN. And if you go there, you can actually see live the blocks being mined. Like this was 16 seconds ago. If we click on it, we can see we can see all of these fields that I already showed you. Same thing. We can actually search all of the addresses here that are on Ethereum, and we can check like their balances. We can check transactions that they've done. And all of the useful info, we can get it from here. Also the current gas price. This was the thing that I was telling you, like this is oscillating all the time, depending on the network traffic. So if there is a lot of traffic, then the gas is probably going to be higher. If there is less traffic, then the gas is going to be lower, right? Okay, let's move on. After block, we will take a look at smart contract. So on the right, we can see a screenshot of basic smart contract. This is actually from Remix. This is also a tool that I'm gonna show to you. It is basically a web tool where you can create and deploy smart contracts. And this is one of their default contracts. So a smart contract is actually an immutable piece of code stored on blockchain. And here is a star because there are some patterns called like proxy pattern that actually allow us to change, let's say, this logic that is supposed to be immutable in a let's say a special manner. But this isn't going to be a topic of this course because it is I would say a bit advanced, but maybe I am going to create a course later on about that. And also every smart contract has its own address. So like when you decide to join blockchain, you are probably going to have your wallet and you're going to have your address there. And also smart contracts, they also have their own addresses. So there are like two types, I would say, of addresses. One is EOA, or externally owned account. This is your account, this is your wallet, and you have a private key for it. And it also has a public key, and this public key is actually used to derive the address. So basically you have this type of address, right? To which you have the public key, private key. And also you have a smart contract. This is also addressed on blockchain, but it has some code associated to it. And smart contracts don't have their private key. And the smart contracts, they also cannot do anything by themselves. So if a smart contract wants to do something, let's say to execute this function store, then an externally owned account, or you need to send a transaction where you actually call one of these functions, and then it is going to be executed. And also, since we are already looking at Solidity here, and we are going to jump to Solidity more later on, let's just analyze some things here. So let's go over this line by line. So first, we see a comment here that is actually declaring the license on this contract that doesn't matter so much. The third line, it says like which Solidity versions are acceptable for compiling this contract. Usually, I like to put a certain address, certain number here, but not an interval. But okay, this is actually accepting the 0.8.2 up until 0.8.9 something. So it excludes everything from 0.9 and above. Okay, and every contract actually starts with a keyword contract and the contract's name that is capitalized. Here on line 12, we have a public variable. If we don't specify if it is public or private, it is going to be public by default. And after that, we have some functions. We have two functions. First function actually takes an argument number and it assigns it to this public variable number. And the other function only retrieves it. But what is the main difference here between those two functions? So if you take a look here, this function actually has additional modifier that is called view. And if something is marked as view, then it means it's basically free. So reading a value from blockchain is free, but changing the state of blockchain, you need to pay for that. So what do I mean by that? So let's say that I just want to read this value of number. I can ask, let's say, validator or RPC. RPC is the gateway to blockchain, as we're going to see later. I can ask RPC with my externally owned account, like, or it doesn't even need to be externally owned account. I can just ask it, okay, give me the value, give me the number of this contract, like call the retrieve function, and I won't pay anything because I'm just reading from blockchain. And if I want to change the state of blockchain, so the state of blockchain is comprised of all of the states of smart contracts, including this one, if it is deployed, and all of the balances on externally owned accounts, and all of the balances of contracts. These are the mutable parts of blockchain. And here I'm actually changing the state value of this contract when I call this function. And because I'm changing the blockchain state, I need to pay gas. And also this remix, this tool is pretty good because it tells to me already like how much gas I'm going to pay if I try to change it. Let's move on. Let's talk a bit about Solidity. So Solidity is a Turing-complete language, which means basically you can, in layman's terms, you can computate anything in it. So you have four loops, unlike Bitcoin scripts, which is the, let's say, script language for Bitcoin. It is statically typed, as we see in here. It is compatible with EVM-based blockchains. So if you know something about Java programming, you have Java virtual machine. And here you also have Ethereum virtual machine. And this Ethereum virtual machine, it actually works on, let's say, bytecode. And you can use Solidity as one of the languages, and you can also use Viper, that is the other language. It isn't so much popular. It is Python-like, and it is not the topic for this course. You can use those two for EVM-based chains. So we are gonna base our knowledge on Solidity, and it is object-oriented. So we are gonna so every object-oriented rule like inheritance, it applies to Solidity also. And the current version of it is 0.8.20. Let's see something about smart contract lifecycle. So first, I am a developer. I'm gonna come and I'm gonna write a smart contract in Solidity, all right? And when I write it, I would need to compile it with Solidity compiler. This is just a short name. I need to compile this Solidity code with Solidity compiler to get the bytecode out of it. And then I take this bytecode and I put it to a special field in transaction that is called data. So in this transaction that I was showing you, there is no field data because this transaction was only transferring value, and this wasn't that transaction type. There is a special transaction type used for creating smart contracts. And you know that you are creating a smart contract if a field 2 is address 0. So if the recipient is address 0, and if there is some bytecode attached to data field, then you know that this is a smart contract creation transaction. We are going to create a smart contract, so we're going to see. And after we create this transaction, this piece of text, we need to digitally sign it, right? And then send it to RPC. RPC is our, as I said already, gateway to blockchain. And basically, people use the most famous providers like Alchemy, heard about it, or Infura, or maybe even you can run your own node. So like you have this client called Go Ethereum or Get, and it is written in Go. And if you run it, you basically have, let's say, entrance to blockchain. And when you send this transaction via RPC, you basically send it to an unmined or unvalidated block. You put it somewhere here, and when this block is validated, it gets included to blockchain, and it stays on blockchain forever. So your code, you need to be that means you need to be very careful when you are actually writing Solidity. Let's jump on decentralized applications. So what is that? Basically, it comprises of mostly two parts, but sometimes there is even this third part. Basically, in blue, these are all components that go on chain. Mainly that is only a smart contract. Here we can see front end. So we have to communicate somehow with this smart contract, and usually people create these beautiful interfaces in React, or I don't know, maybe Angular or Next. Next is used fairly. Where they actually enable users to communicate with smart contracts on blockchain. And this component can be on-chain or it can be off-chain, but mainly it is on-chain. Mainly it is off-chain. But if the application is really that simple and it is small, you can basically put it. So maybe on-chain isn't a really good term. I should probably use something like decentralized storage. So you can actually put it somewhere like IPFS, or I don't know, any kind of decentralized storage if it is fairly small. And then you get distributed front-end code. And also there is sometimes a need for an off-chain component like backend and database. This is especially true if you are like caching, if you're like caching some data from blockchain, or you're doing some kind of analytics from blockchain or something, because usually retrieval from smart contracts takes longer time than retrieval of the same cache data from backend, from database. And if you want to increase your user experience, of course, that you want to retrieve this data quicker. And that is one of the reasons why you would maybe like to use this third component, backend and database. All right. Next thing, here are some, I would say, hype concepts, hype terms for blockchain. So we have to like explain them, because we are gonna do something with this non-fungible term. Fungible, that means that that is a set, let's say, and any element in that set is the same as every other element. And that is represented as ERC20 standard. So we mostly use this for coins. Let's say you have like $1, and every $1 is the same as every other $1. I'm not counting all of the images on them and whatnot, but they have the same value, and we can model them with fungible standard or ERC20 standard. Next up, we have non-fungible. This is like this is a set where no two elements are the same. So we can say like this is the set of images in let's say museum, some museum. So no image is the painting. Sorry, no painting is the same as the other painting. So let's say a museum in Paris, Louvre. Every painting is different there. And if we want to model all of the paintings there, we would use this non-fungible standard. And if you heard about, you definitely did, about NFTs. So this is the non-fungible ERC721 standard. And also we have a combination. We have a semi-fungible. This is a combination between non-fungible and fungible standards. So guys from Engine came with this ERC1155 proposal. I don't know exactly when, but let's say that you have a game, and in this game you basically have some non-fungible things and you have some fungible things. So you're gonna have coins, and you're gonna have, let's say, some special sword or something like that. And if fungible and to let's say model this situation, you would need to deploy two smart contracts, one fungible collection and one non-fungible collection. But with this one, you can actually deploy one contract that is ERC1155, and you can actually insert this combination inside of it. Let's just put like that. So this contract actually allows you to combine multiple collections, fungible and non-fungible. But these two are mostly mostly used, and support for them is, I would say, Web3 has more support for these two standards than for this third one, but there's still also some support for third one. So okay, now we're gonna jump to code, and some of the tools that we are gonna use are here. So like for smart contract development, we are gonna use Hardhat. Hardhat is by far the most used smart contract framework for deploying, testing, and of course developing smart contracts. We are gonna use TypeScript, of course. For the front end application, we are going to use React in combination with Ethers.js. Ethers.js is a library that is going to allow us to communicate with smart contracts that are deployed on blockchain. And also for the RPC, we are going to use Alchemy to connect to blockchain. Right. And the thing is that I already have all of the, I already have a whole application coded out because I wasn't sure if we were gonna make it if we start coding on this session. But all of the materials are gonna be, that is, they are already on GitHub, and I'm gonna share you the link. And if anything isn't clear, if you need additional explanation, feel free to reach me. I'm also gonna put my mail address, and then we can maybe continue the conversation. Okay, let's jump to the code. Maybe it will be good for me to first show you how to initialize the Hardhat project. So I already have two folders here, two modules. One is, as I said, for front-end application, and the other one is for smart contracts. Let me just show you how to use Hardhat. That would be, I would say, best step for starting this. So if you want to create a new, let's say, Hardhat, new smart contract project, you would probably create a new folder. Let's call it test. I don't know. Let's go into test. Let's create a new Node.js package.json. So npm init y. Let's create now we need to install Hardhat with npm install Hardhat. This is probably gonna take some time. But this part is actually really important, and I wouldn't like to skip it just to show you how to set everything up. And after we set everything up, we are going to jump in this smart contract directory, because I actually created it in the same way as I'm going to create this test. So now when we install the Hardhat, so it is here in our package.json. Sorry, here. Okay. Hardhat, and now we need to initialize Hardhat structure in this project, in this module. So we write npx Hardhat, and it's gonna present us. I hope you guys you can see everything here. It is gonna present us with three options. So create JavaScript project, create a TypeScript project, or create an empty Hardhat config.js. We're gonna choose the second one, create a TypeScript project. Okay, Hardhat project is here. We want to add a git ignore. Okay, and we want to we mainly want to install these additional dependencies. They're gonna be good for testing contracts. Yeah. And after we do that, we are just going to go through this folder structure that Hardhat actually initialized for us to see, like, okay, to see what is there. Okay, basically now what we have contracts, scripts, and test. Also we have this config file and node modules. This is fairly known thing. I'm gonna go through this. Let's go first through contracts. So Hardhat actually created one test contract called lock.sol. So every Solidity file has an extension .sol. And now, as we already talked about, we can see like a version that's specified here, a contract name. It has a uint public unlock time variable, and it also has address payable public owner. It also has a constructor. So if you have already programmed with, let's say, JavaScript or Java or something like that, this is going to be fairly easy to. I mean, fairly. It is going to be definitely easy to read the syntax to you, because I would say that Solidity code is really readable. That is, if you wrote it appropriately, but the code in itself, the keywords and everything, it is really, I would say, easy to read. Okay, so it basically created a smart contract for us, and we also have some scripts. This is a script for deploying this lock contract. We are also going to analyze this on my example. And we also have a file for testing, also written in TypeScript. So if you ever use like Mocha or Jest or something like that for testing your JavaScript code, this shouldn't be something very unfamiliar to you in terms of syntax. And we also have this hardhead config where we actually specify like which Solidity version are we going to use for compiling. And we also include additional, let's say, plugins for hardhead here. Let's delete this folder. We aren't going to use it anymore, and we're going to jump to our smart contracts to see like what do I have here. So for our workshop, I plan to deploy a small ERC 721 collection, and to show you how to do that. So I have a contract that is named Fellas, and let's analyze how does it work. So what do we have here? First of all, if you can see, I am importing some additional contracts, these two lines. So I'm importing ERC 721, and I'm importing ownable for some package from some package that is called OpenZeppelin contracts. So OpenZeppelin, let's see what OpenZeppelin is actually. OpenZeppelin, this is actually a standard for secure blockchain applications. So as I've mentioned already, you need to be very careful when you are writing Solidity smart contracts, because you are actually playing with real money. I mean, crypto, but it has value. And these guys have already battle tested some, let's say, paradigms, and they have their contracts, base of contracts like ERC 721, ERC 20, all of those standards that are secure. And when you are actually writing, as we are doing here, when you're actually developing, let's say, NFT ERC20, of course, you can write everything on your own, but it's best to use to inherit. See, here's a cool word is to inherit from their already made contract. So you can actually see, like, when you go here, when you check out their contracts, maybe we can go to documentation here, contracts. Okay, we can actually check. So I actually inherited from this one, from ERC 721 contract, and we can check its let's say API, let's say its documentation. So it basically has all of these functions. And when you click on one of those, you can actually see what this function does. But I'm going to leave that to you. So basically, you should read through the OpenZeppelin documentation, because you are mainly going to use their contracts to deploy your own things. What else? What is important to say? Yes, when you want to use this OpenZeppelin contracts, you basically need to install their contracts as a package. So from here, from npm, don't worry, I'm gonna aggregate all of these links and upload them to push them to GitHub additionally after the course. So everything that we visited. So here you can actually see a small example of how to include it, but you need to install their contract. So, okay. We are actually inheriting from ERC 721 and one special contract that is called ownable. So sometimes we don't want to allow anybody to call some functions on contract. We just want to allow, let's say, admins or us or the deployers, whatever. Let's say here, this withdraw function, it actually enables us to withdraw all of the money that is accumulated in this contract. And we, of course, don't want anybody to call this. We are owners. We deployed this contract, and we are actually selling our NFTs here. Money is gonna accumulate in this contract, and sometime we want to withdraw it. And that is why we are using this modifier, this called only owner here, to limit only us. So we are the only ones that are able to withdraw. If we check like what is this only owner, what is it doing actually? Okay, so this is actually a modifier, and you can declare your own modifiers like this modifier, name of the modifier, and then the body. And if you declare a modifier, then you can use it like this at the modifier sections when you are declaring your own function. And what it says here like when this modifier is used, first call this function, check owner, and then continue with the rest of the code. So like when somebody calls this function, it is first gonna execute this only owner, and then after that, if everything is okay, it is gonna execute this. So if we check this check owner, it says like require that the owner is equal to message sender. And the message sender is actually the caller of this function. And if we check like owner, what is owner? Owner actually returns the variable owner, and this variable owner gets assigned to our address when we deploy this contract. So when we actually deploy this contract to blockchain, the constructor is going to be called, and it is going to in turn call the constructor of ownable and ERC 721 token. And here, this constructor is also going to be called, and it is going to transfer ownership to message sender. So to anybody who actually deployed this contract. And it says like it is going to set this owner variable, as you've seen, to the new owner, to us, right? Okay, so let's start maybe. Okay, and then we actually have this maybe I should explain this first. So we have three public variables that are going to be important for us. One is the token price, so price of a certain token. Then how many tokens are we gonna sell? And what? Sorry, this is actually what is the next token that is gonna be sold? This is like an iterator that goes up to max supply. This is the maximum number of tokens that are gonna be sold. And also we have a base URI. So base URI, if you've seen like collections like Bored Apes and all famous NFTs. All of them, they have their own metadata. And this metadata is mostly uploaded to a decentralized storage like IPFS. And it is actually addressed by its base URI. So like if I use this base, so let me just show you how does this base URI look. So this base URI looks like this. This is going to be the base URI for our token metadata for these fellas that we are going to deploy. And if we go, let's say, to this address and write 0, 0 is going to be the token ID of a certain token. So we are going to have IDs from 0 up to 5 because there are going to be 6 tokens at most. And if we check this out, Okay, I cannot visit it with my default IPFS. I can maybe use Pinata gateway. Okay, this is the Pinata gateway, and let's just replace this link. IPFS not connected. Okay, let's try to. Okay, good. Okay, so this is the OpenSea, let's say, metadata. This is the, if you want to create a metadata for your token, it has to follow this standards. So it needs to have it is a JSON file. It needs to have a link to image. This is also on IPFS. If I copy this, I'm gonna be able to see. Damn it, this doesn't allow me to go. Okay, good. This is the image of this token. These are its attributes, like can be whatever. It only matters that it says like trait type, then the name of that trait, what is its value, and then you actually add multiple trait types here. So every token is gonna have metadata associated to it. So if you check like number 1, this is gonna be for a different token. If you see like this value is tightened, it's changed, its image changed, and blah blah blah. So every token has its metadata, and this base URI is only the main part of it. So these numbers up to, from 0 to 5, they're gonna be assigned dynamically, as we're gonna see. Okay, with this function. Okay, let's maybe go through constructors. So basically, this contract actually expects that we say what is going to be the token price, what's going to be the max supply, and what is going to be the base URI. If we are inheriting, as we are doing here from ERC 721, this ERC 721, as we see, it also has a constructor. Let's change it. Let's find it. Constructor, and this constructor, it expects a name for collection, and it expects a symbol for collection. So we also need to put 2 parameters here. And how do we do it in Solidity? We don't use, I mean, we can use word super, but this is the most common way to do it. So basically you give the name of that contract here, and you put those 2 arguments there. So the symbol of collection and the name of collection. And then you set all the remaining variables, public variables here. All right. And okay, now at this point, our contract is initialized. And let's just analyze some of these functions. So if somebody wants to buy a new token, if somebody wants to, as they say, mint it, they're going to call this function. So let me just say that there are 4 basic visibility modifiers. So we have external, we have public, we have private, and we have internal. So what is the difference? What is the difference? So external. When something is external, it can be only reached from outside of the contract, from outside. So you cannot actually, let's say, call this function, and then this function in turn, somewhere in its body, calls this function. This cannot happen because this function cannot be called internally. So you can only call it externally. If a function is public, then it can be called from outside and also from inside. But if there is no need for something to be public, for example, we don't want to call this mint inside of the contract, then there is no need to make it public, because if we made it public, we would have to pay more gas for deploying this contract, and we just don't want to do it. Also, here is one interesting modifier that is called payable. So if you want, as we've seen already with this transaction that I was showing you at the beginning, there is a field called value. And when it has this field called value, that means it is actually transferring money somewhere. And if you want to enable your smart contracts to accept money through some function, you need to make this function payable, right? It is not going to allow you. See, I already have an error. it says like message value and call value can only be used in payable public functions. Make the function payable or use internal function to avoid this error. So we need to make this payable. And the thing is, see, like if I want to check the value of the transaction, I can use special field called message.value, and I can check like okay, it needs to be greater or equal than token price, and if it isn't, then I am reverting the transaction and saying token under price. One more important thing that I have to say, like let's say that that we said something like this: token price is equal to I don't know 5, whatever. Now, and then we call this mint function, and we send a value of 4 way. Although we already changed the token price to be 5 here, the whole transaction is gonna revert here. And if it reverts, that then it means that all of the changes before it, they weren't applied. So token price is not gonna have a value of 5. It is gonna have the old value that it had, except if it was already 5, then okay. But let's say that the token price before I set it to 5, it was like 3, and I set it to 5 here, and transaction reverts here. So token price goes back to 3. So nothing actually happened. No state was changed on blockchain because the transaction was reverted. All right. Next thing, we also check like where the old tokens minted, and we say make supply minted. And after that, we actually mint the next token ID to message sender. And after we mint it, we use a little optimization here, then we increment it. That's it. And withdrawing this, I already explained to you, but let's check out this transfer function. So transfer function actually wraps this message sender. This is the type of address. We need to wrap it inside of payable, just so we can use this transfer function. It doesn't allow us to do that on a pure address. Now it's a payable address. And then we transfer balance of this address. So if we want to check like how much Ether is here on this contract, we can use this expression. Also, we have a setter for base URI that only owner can call it, and we have a base URI here. This is the thing that we overridden. That is just going to return the base URI that we set here, because every ERC 721 contract, it actually has a function called token URI. And this is called by OpenSea when it wants to retrieve the metadata of the token, like the image and all of the details. It is going to call this, and it is going to enter the token ID of a token that it wants to retrieve the metadata for. And if you see here, it says like if there is something in base URI, if it is greater than 0, then it's going to take, it is going to concatenate the base URI, the one that we set, this IPFS thing. It is going to concatenate it with token ID to string. So like if we are asking for a token 0, it is going to take the token, the base URI, and concatenate the token ID with it. And then we are going to get one of the links as I've shown you before. And then OpenSea gets that link, reads all the metadata, and then shows the token to you. Great. How much time do we have left? 47. Okay, let me just show you then how do we deploy it. Maybe we aren't going to have much time for this, but everything is going to be on GitHub, and I encourage you to contact me and to ask me if there are things that need to be explained additionally, but feel free to reach out. Okay. Let's try to deploy it. So if I want to run this script, this deploy script, it is going to first take these deploy arguments. These are the constructor arguments that I already told you about. Then it is going to retrieve the factory for creating this fails contract. We do it like this. And then we deploy this special type of transaction for creating a smart contract with this. We await until it's deployed, and we are gonna get the confirmation where is this contract deployed at. I mean, we don't actually have to go through this procedure because I already deployed it here, and it was deployed at this address. So maybe what can we do? Because we don't have much time left, I can show you how frontend actually works with this. It seems like I won't be able to won't make to explain the whole frontend to you, but okay. So I have already connected this deploy smart contract to frontend, and basically we can use this button to mint a token to us. So it says like here I can connect my wallet. Okay, MetaMask. I'm connected with this address 0xe60 something. So let me just see if this is the right one. Yes. And when I click on mint, I get the MetaMask transaction. Okay, I'm paying some of the value. It says where it is $0.01. That is the token price that I've set. Okay, a second, MetaMask problems. I confirm it. And let me check if it is going to be mined. Mint. Okay, it was minted. So this is the transaction. So when I copy the transaction ID, we aren't using Ethereum testnet. We are currently on Mumbai testnet. So this is the Polygon's testnet. Polygon is also a blockchain, a sidechain, and this is its testnet. So we can see like this was the transaction ID, and we can see like tokens transferred. ERC721 to token ID 2. Fellas, this is my collection. It was transferred from this contract to me, to my address. Here it is. Okay. And I can also check something out. OpenSea has their own testnet. So if I go like OpenSea testnets here, it also supports this testnet, this Mumbai Polygon's testnet. All right, I'm connected to my wallet. I can go to my profile, and it is going to show me all the tokens that I have. So these two were pre-minted before, and this one is new one. Okay, something is buggy here, but it seems to me that they load. Okay, here it is, the metadata and everything as it should be. But anyway, no, this is something buggy there, and but if we zoom here, like we can see, okay, it has its image, or at least it had. I don't know why it keeps disappearing when I hover it. It's so weird. Okay, here it is. The image, but unfortunately, I cannot see more details regarding it. But that is only because they, I suppose, have problems on their testnet. Anyway, we can see that the image is loaded, so it means that it's reading from the JSON file that we put up there. And unfortunately, guys, I'm gonna have to end this because I don't have any more time, but maybe we can go to this front end on some other occasion. But as I said already, all the links are gonna be on GitHub. I don't know where can I share the links. Maybe I'm gonna speak with Benedict or somebody regarding that. But okay, let's say that somebody's gonna forward them to you. And I would like to end here, maybe stop sharing because I have like a little more than 5 minutes, and that isn't really enough for me to continue.
Marko, hello again. Thanks so much for the talk. We still got some minutes, so I would say let's make a real quick Q&A, if that works for you.
Yeah, sure.
Yes. Maybe more of a general question. Do you have some resources to check for a beginner?
Okay, yeah, sure. I actually stumbled upon a nice collection of, I would say, beginner resources that I can share to you. But currently, I don't have the link. I have to dive deep somewhere where it is stored, and then I can send it to you.
You can send it to us in our private chat. Then we can post it in the general chat for you if that works for you.
Yeah, definitely.
Afterwards.
Yeah,
perfect.
afterwards.
All right. Thank you, Marko. Another question. Are there alternatives to Ethers.js?
Yeah, there are. Actually, I didn't start with Ethers.js. I started with Web3.js, but it was used less and less. So most of the guys, I believe, switched to Ethers. So yeah, there are.
Okay, it's a trendy thing to do.
Yep, definitely.
All right. What do you think will be some future real use cases for the blockchain?
That is a good question. For real use cases, well, currently, everything that is, whenever you need a transparency, whenever you need like some distributed, let's say, database that cannot be changed by an individual, but consensus, that is a perfect use case for blockchain. So maybe one good use case is, I mean, people are doing it. It is the, how do you call it, the chain of supply, the traceability of products. That is a good use case, I would say. Yeah.
All right. Thank you, Marko. A more basic question also, what are the fundamental concepts in blockchain theory that Web3 developers should grasp to become more effective in their development work?
Well, I would say the security definitely regarding solidity, because you need to be, as I said already, it seems easy. I know it is easy when you get a grasp of like a few concepts around it. You think that you know everything, but believe me, you don't, because it can get very tricky. And I could basically create a whole session where I explain all of the security, but that is, as I said, a more advanced topic. Yeah.
Maybe next time on the next Web3.
Maybe.
You have,
yeah, definitely.
We already have your topic idea, so let's go for it.
Sure.
All right, Marko. Next question. How would you start getting into blockchain development? Is there a guide? Maybe.
Yeah. That is a good question. So I started by, this promotion by checking by going through the course on Udemy from Steven Grider. That is a brief guide to Solidity, but currently it is very, I don't know if it is updated. It is, Solidity is moving rapidly, like new versions are coming every month, I would say, and updates, and this is working with old version, but for beginning, it's okay. And then you can jump to documentation and everything and figure out on your own. Yeah.
Okay, let's jump from the basics to an outlook to the future, because we also have a question. What are some potential future trends or development in Web3 technology that developers should keep an eye on?
Oh, good question. Well, zcase, I would say. So there are some, if you already heard about it, if you didn't, take a look. It's a complex topic. I don't know everything about it, especially the cryptography. It's called zcase, so zero knowledge proofs. And there are actually, these are the, I would say, optimizations for blockchain in a sense, where you don't need to know all of the informations to figure out that something is true. So it's a really a complex topic, and I invite you to check it out. So this is currently hot topic.
All right, thank you, Marko. Another question. What are some prominent mechanisms for smart contract interactions in the Web3 ecosystem?
For smart contract interactions, well, I usually interact. I don't know if I get the question, because usually you interact with smart contracts via front-end application. This is the part that we didn't make it, that we didn't do today. But usually you have these libraries like Ethers, like Web3, where you communicate with smart contracts. Now, I don't know if I got the question right, but that is my answer, yeah.
All right, thank you. Maybe as a closing question also to you, maybe you want to share some insights on how you became interested in tech and ended up where you are now with your own company?
Yeah, sure. So basically, it all started in my college, back when I was in college. So like 2016, 2015, I don't remember actually what year it was. That is when I started freelancing, and I was basically writing applications in Visual Basic, C#, and all of these old technologies. And then I got my first job that was supposed to be a Node.js developer, but actually, with many twists and turns, I started developing smart contracts somehow. And I also, I'm also proficient in backend development, so like Node.js, TypeScript, Express, and all those things. And that is basically when my adventure with crypto began. It was all interesting to me, like this distributed ledger and how it all works, how it has value, and now you can do smart contracts and logic and everything around that. And after that, I started my own company with my partner from Hamburg, Germany. And yeah, we are currently working on our in-house product. And we also do a bit of agency work, like we help other companies to deploy their Web3 or web solutions. So yeah.
All right, Marko, thank you. Thank you so much for the talk, also for the Q&A, and good luck with your company and your in-house product. Looking very much forward to the finished one. And as we have the next topic already for your next talk on the next live day, I would say until then.
Yeah, until then, Benedict. Thank you, and see you.
Have a nice
Bye-bye.
one. Bye.
You too.
All right, and before we jump to the next speaker of the day, 20-second break.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
And now for the third speaker of the day. He's CEO at Hololux, GmbH, is a Microsoft MVP, and he loves to share his insights into the metaverse and the opportunities that it offers. Very welcome, Christian.
Thank you, Benedict.
Hi, Christian. Yeah. Happy to have you. How are you?
I'm great. I'm looking forward, to share all my passion about the metaverse with the audience and Decentraland.
Perfect. So maybe can you give us a quick lookout on what we're going to learn from you today before we start?
Sure. So yeah, we will talk a short time at the beginning of this introduction a little bit about metaverse, what it actually means, how the potential in general of it is, and then we take a look more in detail into the Decentraland as one of the most famous platforms, and how you can leverage that as a developer also for new business models, new ideas, or customizations.
So very much takeaways, I would say. And before I steal any more of your talking time, I would say, stage is all yours, Christian.
Thank you, Benedict. So, okay, then welcome everyone to my session, Exploring the Potential of Decentraland. And yeah, today we explore the exciting world of Decentraland. And Decentraland is one of the most famous metaverse platforms. It's built on the Ethereum blockchain. And we will check how it unlocked economic opportunities for artists, businesses, and for sure for developers. So my name is Christian Glessner, as you heard already, and I'm the CTO of Hololux. And I guide some of the most vibrant brands on their journey into the metaverse. So we work, for example, very close with Microsoft and with really large international companies together, and check how we can how we make their vision and mission true in a completely new emerging digital world, the metaverse. And yeah, my passion for computers started early. My parents had a travel agency in Germany, Saarland, Saarbrücken. Some people think it belongs to France. But however, and they invested in IT early on. And I still can remember very well as a child when I stared for hours into the amber sparkling screen of an IBM AS400 and the promising blinking cursor, ready. So the tabula rasa, the chance to create something completely new out of nothing. is still what drives my passion into software development till today. And for sure, with the emergence of metaverse, mixed reality, extended reality, AR, VR, however you call it, my childhood dream has come much closer to reality. And yeah, as Bennett mentioned also, I'm also very proud that I was awarded with the Microsoft MVP award now for 13 times in a row. Not sure if you know what it is. Actually, I call it the Oscar for Microsoft. You have to get it once a year for contributions in community, like talks that I'm doing here or open source projects, different things in the community. So let's start first with this, with this recent buzzword, metaverse. So as we begin, it's essential to understand there is no universal accepted definition of the metaverse. However, most people agree that it represents the next evolution of the internet. I would even call it the next revolution of the internet. And I think when we talk these days about metaverse, I think it's a little bit like we talk in the 80s and 90s and imagine how would the internet technology, TCP, IP and everything, how would it change? How would it look like today? And what we see, we have complex website on it, e-business, e-commerce. We use technologies like StreamYard, Microsoft Teams, and many different things. So I think it was also hard to predict in the 80s, 90s how the metaverse would change our life today. And so it's a little bit with the metaverse when we talk about this right now. Imagine a world where the internet transforms from a primarily 2D web-based experience into a 3D interactive and interconnected ecosystem. Yeah, that's what the metaverse aims to achieve. So it will seamlessly integrate our digital and physical realities, allowing us to become an integral part of the online world. It's not just we surf on a website, we will actually dive into a website, we will be part of the metaverse. So it will be a much more immersive version of the internet that we know now. So picture yourself entering a virtual brand showroom from a company where you can not only engage with others, you can engage with AI, you can explore products and fully immerse yourself into the online, into the brand world. As we look forward to the future, the metaverse promises to unlock new possibilities for creativity, collaboration, innovation. So one important thing, it's still not there. You know, everybody talk about it and every platform call themselves metaverse. You put it in front of kind of everything. So one thing is sure, it's currently, it's not there. It's an idea. It's more a future state that we will reach. And when we are there, actually, nobody will call it metaverse. We will call it reality then. But it helps now to guide people in that direction. So there is currently no real metaverse there. It might even take 5 to 10 years till we are really there. There are many challenges to solve. There are things like you see it in the massive online player games. There is still concurrency. How many people you get in one experience? It's still challenging. And then we have hardware challenges. The glasses are still not in the right, are not still fashion, I would say. So most people don't want to wear it or they don't have the hardware. There are also technical challenges in this. But soon Apple will also bring their first device and maybe it will change it. But there are many challenges to solve to make a real metaverse. So let's lead the potential. The latest study I know here is from Citi. It's by also a customer of mine. They said the metaverse economy could be worth 13 trillion by 2023. And so you see there's a lot of potential there. And actually it remembers me also when the term cloud computing came, people also discussed about, is a web hoster, is that already cloud computing? What is cloud computing? And then we saw also that research institutes pushing out all the numbers, how the market might develop. And actually, you don't think about it anymore, and it's there now, and it's really a big market. And same will happen with the metaverse. So the metaverse brings together a variety of cutting-edge technologies, and over the next year, these technologies will converge and reshape our digital landscape to something that we might call then metaverse. So in one thing that's important for the metaverse are virtual worlds. We know that maybe from Minecraft. Minecraft themselves call them also now a metaverse. We know that from online games, massive player online games like Fortnite. And as I said before, there are also challenges how many people you can concurrent people you can bring in one experience. So it's still also some challenges in the virtual world area. And then we have Web3. So Web3 and blockchain technologies will play a crucial role in the metaverse, enabling secure ownership, identity management, and seamless payment. So, Web3 stands also for decentralization and things like this. So it's one of the components that is important to make the vision of the metaverse true, because most people think there will not be just one metaverse, there will be different ones. And then when you buy, for example, now in Fortnite, you buy a skin. Yeah, actually, sometimes I have to buy that for my daughter. Never thought that I would spend money on virtual fashion, but you buy it there and it just lives on that one platform. I cannot take it to the next one. When that game is gone, it's gone. So there is already a mechanism like this. But you want, when you buy, I don't know, you buy a Chanel or a bag or something like this, and you may want to take it from Metaverse A to Metaverse B, and then you need a mechanism how to do that. And Web3 technologies are a foundation for this kind of ecosystem. So then we have AR, VR, what's also mentioned as mixed reality together, or you hear also the term extended reality, XR. So this is imagined that at the technology foundation of that thing. So we built a World Wide Web with HTML, JavaScript, CSS. Actually, it's still the basic of it, and we have a lot of frameworks on top of it. And imagine a little bit that these technologies are also the foundation, like JavaScript and HTML, for building the next evolution of the internet and metaverse. So, and then, while artificial intelligence may be not the first thing that comes into your mind when discussing the metaverse, it's indeed a vital component. So I'm not a big fan to, hey Siri, or talking with a device. And the metaverse can give actually a AI a shape, a body, emotions. You will not even see if that on the first place, if you're talking with a human or an agent. Just maybe a few years ago, you think it maybe wouldn't be so smart, but now with technologies like ChatGPT from OpenAI, you see AI has a lot of potential. And imagine you have an agent that is driven by ChatGPT, OpenAI, and then there are also development direction, that the voice can also show emotions. So we will see a complete new level of how we can interact with AI. But this is not the only thing that we can do with AI there. So there is also the combination of virtual worlds and AI. And we see that a lot in the topic of industrial metaverse. Imagine you have a factory or something, and you build a really very close digital twin of that factory, and that's even photorealistic. What you can do then is you can generate, you can train AI in this environment. So you don't do it in reality, you do it in an artificial environment, and this is much faster. You can have many different variations of that thing, and so you can train AI much faster. Imagine an autonomous robot that should drive and maybe pick things and drive it from A to B. Training that in reality is a lot of effort and takes a while. But in the metaverse, you can just simulate it and make it much faster. So there are many things where AI can influence the metaverse. So, and then one thing that is also important to understand why also that technology is important, or why it will be the next breakthrough. There was an interesting experiment in, I think it was 2001 in Stanford. They also had a virtual room scale virtual reality. That means people could already walk around in that room. And what they did a study about how people walk in that environment, track the path. And the first thing they did in the experiment, they put a basic object inside, I don't know, like a cube or like a sphere or like a cylinder, just some basic objects. And then they checked what the people what they do and how they interact with the object. Yeah, and they They went to that object, they put their head into it, they walked through the object. They interacted in every possible way with it. Then they changed that experiment. What they did is they put a human-looking avatar inside of that experiment, sometimes eye blinking and a little bit of head movement, and they checked what the people doing then. And what they found out is what they took exactly the same way how they would walk when there would be a real person, the same path. And what they did is they kept the same personal distance, how we do in German, comfort zone, at a personal distance. This is not something we do on purpose. When we talk with people and we see they're coming too close, we feel uncomfortable, but we never think about this. So it's just an instinct. And what they could prove there already is that mixed reality, the technology foundation of the metaverse, is the first communication technology that is able to trigger your instincts and touch your emotions. And imagine what that means for a world where marketing and everything is for years already mostly based on emotions, and human decisions are also mostly based on an emotion and an instinct. And in COVID, there came also the term Zoom fatigue. Now they call it a little more brand neutral, like video fatigue. And this is because a technology like we are using now with StreamYard, for example, or with Microsoft Teams or Zoom, it's not immersive. For our brain, it does not feel real. So it would be hard to scare you here somehow in that video chat. So this would not work. And people, we need to work with others together. I think our largest strength as humans is we can work together. A single human cannot achieve much. We have to work together. We have to communicate and we have to collaborate. And this is even part of our genes. We need that. And that symptom from video fatigue and everything came because actually the people did not have the feeling of social presence anymore. And these new communication technologies are able to solve that. So, but one thing here first, many platforms still do not support really immersive virtual reality. Many platforms only have a 2D client. So the problem here is they don't focus so hard on the 3D stuff because not many people have a 3D gamer hardware. They don't have the glasses. So the hardware is still not really everywhere. So many start with let's say a lower version of the metaverse and having a 2D experience, for example, like Decentraland. But Decentraland already, a team is already building a virtual reality client. There are even some versions available of that. I personally think that's the secret sauce of it, because in online games, running around in a virtual world, that's not really new. But having the feeling to be completely immersed and that it feels real for our brain, I think that's the secret sauce of the metaverse. But as I said, there are still some challenges in that area. So let's go to Decentraland. So what is Decentraland? Decentraland is a decentralized virtual world where users can create, experience, and monetize content and application. It's powered, like I said before, by the Ethereum blockchain, and ensuring that every piece of land and wearable and in-game asset is truly owned by the users. This creates a thriving where users can buy, sell, trade, kind of a virtual economy. And you can take it because it's blockchain technology. You can trade it also on another platform. But let's say also you see compatibility is hard. How you bring something from Decentraland to more a voxel experience. So there are many also wearables. It's a lot of challenges to solve regarding standards. So, but before we dive a little deeper, I think maybe not everybody saw Decentraland, so I show you a small video that you get a first impression how Decentraland looks like. Yeah, so this was a music festival last year in Decentraland, but there are many different things like Fashion Week. Also, I think MasterCard did also larger events last year. So there are a lot of events ongoing on Decentraland, and to give you a little bit feeling how it actually looks like. So then Decentraland, like also the other platforms, they have their own currency. It's called Mana. It's an ERC20 token on the Ethereum blockchain, but it's even a little more complex. We don't go too deep into this, but you have to exchange that for some transaction into Polygon Mana, because in the app it saves gas fee when you use Polygon Mana instead of the Ethereum Mana. But yeah. So what is Mana used for? It's used for purchase virtual land, goods, assets, wearables, in Decentraland, even services. And as the platform grows, the demand for Mana, that's ideas expect to increase, and providing economic incentive for developers and businesses that participate in that ecosystem. So like with all the cryptocurrencies. So what you can do, or what is important in Decentraland, you can buy virtual land. So what you see here is the whole map. It's limited to exactly that ground, because when you limit something, it creates value. This is even in an abstract concept like a virtual world, limit is quite important to make something valuable. So, and you can buy and trade here virtual land. So in Decentraland, the platform is made up of parcels of virtual land, which can be bought, sold, and you can develop your own experience on it. And yeah, just in like the real world, location matters. So you want to, the better location of your virtual land, the more value and pricey it becomes. Prime locations near a popular hotspot like the Genesis Plaza, which is the entrance of Decentraland usually, or interesting landmarks, or you build a shop beside MasterCard or Dolce & Gabbana. It's more expensive, or on the crossroads. So it's really pretty much like in reality. And then there's recently also a new change, because it's also quite, or let's say it's a little pricey to buy in when you want to start to building something on Decentraland, or not everybody want immediately to buy ground. So recently they introduced also the concept that you can actually rent land. So and we see it's maybe a little small here to see, but here you can filter on if you want to see all land for buy, for rent, and then you see how many parcels actually somebody offer. And just to get a feeling about the pricing here, currently the highest price that Mana every time price, I think it was around €4.80, and it was around end of 2021. Currently, because you see all the blockchain is much lower in value recently. So currently it's 0.43 is €1. So it's 10 times, it lost 10 times value. So it's still a good moment to buy in a land or invest in Mana, but for sure there is a certain risk. And a parcel, which is 16 square meter, is currently around 4,000 Mana. But as I said, it heavily depends on the location. So it's just to get a feeling. So let's say for one parcel, 16 square meter, you currently pay around 2,000 euro for buying land there. So, and we are a big fan of eating your own dog food. So for sure, we have also our virtual brand experience, which I also want to show in a small video, a little bit of the making of and how our own office looks in Decentraland. Yeah, so this is a little bit of the making of our own office. What you see there is for many web developers or for developers, this is often challenging already to build a 2D UI. And imagine it does not get better with a third dimension with 3D. So what you also see that building really cool experience is getting more complex from the team. Usually we see here a little bit of concept art. You need a concept artist, you need a modeler, you need maybe a shader artist. For Decentraland, maybe not so much. You need a technical artist, and then you need for the interactions, you need then a developer. So the workflow gets a little more complex in that 3D world. And what you also saw, there were some images around and some content. Actually, we use Strapi as our headless CMS, and we actually have Decentraland as one of our channels and change content in our office based on our CMS. And I think that's something that we will see very natural in the future, that it will become a new channel of the Omniverse marketing strategy, and people will use the CMS also to bring the content into this metaverse experiences. So, and yeah, there are maybe some less famous brands than ourselves in Decentraland, like for example Coca-Cola or Samsung, Nike, Atari, Mastercard, Dolce & Gabbana, Ford. So there are many different companies on that. Some go to Sandbox, some go to every platform because you don't know which one really succeeds. Others, go to A or B. But what we see around our office, there are more and more companies building things. So, and then there's another topic which you also can use to make revenue. Let's take a look at wearables in Decentraland. And it's a fantastic opportunity, especially for designer and artists, to showcase their creativity. On the slide, you can also see we did a Bits and Pretzel collection designed for the Oktoberfest in Munich. So you can now wear traditional Bavarian clothes in Decentraland. These unique assets are tokenized as NFTs on an Ethereum blockchain. And you can trade them in Decentraland or even then in OpenSea or on other platforms. So, and designers and artists can create wearables such as our Oktoberfest theme collection. You, by the way, pay also a publishing fee, and that fee, you will see later on how that fee gets used by Decentraland, that you have to pay for something like this. This does not only allow them to display their artistic talent, but also contribute to the vibrant Decentraland ecosystem and to generate maybe additional income. And I think everybody see that or can agree on that with NFT. You can, when you make the right things, you can make a lot of money. You know, the Bored Ape Yacht Monkeys. So this one was 3.5 million around. And what do people with it? I think Madonna and Justin Bieber, they bought their things and they use it as a status symbol, for example, for their Twitter profile or something like this. But in Decentraland or in their platforms, you do not have just a 2D image. You really can wear things. So, a very important concept of Decentraland is also decentralized autonomous organizations. So this is a crucial aspect of Decentraland. The DAO is the governing body responsible for marketing, for making decisions and managing the platform organizations. In Decentraland, the DAO is responsible for many different aspects, like managing the platform smart contracts, deciding on platform upgrades, resource allocation. It oversees resources, just as fundings for different developments or community projects, infrastructure and development, and even for organizing marketing initiatives. This is all controlled by the DAO. Or maybe 1 second, one back. What's interesting, it's also kind of a political system. This Decentraland system combines something that you call a liquid democracy and a plutocracy. Liquid democracy allows users to vote directly on proposals or even to delegate their voting power. That provides a flexibility and inclusivity. And plutocracy comes into play about voting power. And voting power is determined by the ownership of assets like land and mana. And as more land and mana you own, as more voting power you have. And this is called a plutocracy. So it's not completely new in human history, but this is the governing system that we currently have on Decentraland. So in here, a real example, this is part of the virtual reality client that I told you. It's actually, it's a friend of mine who built that. It's Sean Ong. Yeah, and he, that's just from last year, May, he got a second grant. The community vote for it, discussed the proposal, and he got the second grant for, let's say, a $250,000 US. And actually, I counted together. So Sean was able to fund around almost $600,000 US for building that virtual reality client, and it get completely funded by the DAO. The people vote for it, and in the end, he gets the money transferred to his, you see it, to his blockchain address. So, and yeah, here that's Sean, you see, is very happy, a lot of funding. So that's we meet recently in Seattle. And Sean is really heavily active on that platform, and I'm really looking forward that for the virtual reality client, because as I said, I think it's part of the secret source. So a part that usually more the designers do is they use Decentraland Builder, where you can arrange things. You can upload your own compositions, or they have some basic assets that you can arrange there as building blocks. But yeah, you can also build on different platforms, marketplaces, different assets, and place them in that Decentraland Builder. And you can export it then, and you bring it to the Decentraland editor. And this is where you as a developer comes in. Here you can develop games, interactivity, or like we did, integrating our content management system. So it's you do the development in Visual Studio Code. They have there even a Visual Studio Code add-in for this, just to understand very roughly how how the mechanism works. You have it's by the way, it's developed in JavaScript/TypeScript. So you have the highest in the hierarchy of the components is the engine itself, and under it's the entities, which is just a kind of a placeholder, an ID to identify, let's call it a game object. And then you have components which actually brings in the behavior for your entities. You have a component like a transform. Actually, a transform says that's the position and that's the scale of the object. Or another is maybe is the shape of it, the mesh, or other interactivity. So entity is just a placeholder, and it's all the behavior and how it looks like is defined by its components. And then we have also something it's called systems that brings the interactivity to your entities / components. So to here a small code example, you can create. Let me switch the pointer here. You can create a mesh entity, add the entity to the engine. It's, as I said, just a placeholder with the ID. And then you can create a transform. That's a component, as I said, defining the shape and the dimensions and the scale of the component. And you add that to this entity, and then you you said what shape it should have. It's actually, there's some basic geometries like a box, and this will become a box. And then you have also a concept that's called collider. This is actually, without a collider, it's just a shape. I'm not sure how deep you are in game development, but with a collider, you get also interactions when somebody maybe touches a collider, it triggers a collider. So, and beside something like this, you can also, add things like GLB files, means 3D models, instead of just working with basic geometries. So then there's the systems, which brings actually the interactivity in it, the dynamic. So here's, for example, a move system. And then you use a query to query entities. Here we say every entity that has a transform component, we we loop through all the components, then we take every transform of the component, and this one update the position value set to it. That means we move the component just forward. And what's also important with the system, it's really like coming from the game development. This gets fired in every game loop. This component will gets fired move system, and so it will make a 001 plus for the Z axis, and so we move the object forward. So, but let's have a look how it then actually really looks in Visual Studio Code. So maybe make it a little larger. Hope you can see that well. So this is a template. You can really create it directly from the add-in from Decentraland. Maybe it's hidden now. Yeah, you see. By the way, I use here the beta SDK, the SDK 7, so it's maybe a little different. It's currently beta. Then you see it in 6. But yeah, they have here their plugin where you can run a scene, and let's do that. So this is just the basic template. What will happen when you run the scene? And from here, you can also publish it. So I think it's quite well integrated into a Visual Studio Code. Well, that's that's perfect. You know, it always works. Only not when you want to show it in a demo. Let me open it again. So it just crashed. Wait a second, have to open the project again. So here we go. Maybe in the meantime, while it loads the SDK and all that components, let's see what we discussed before in a theory. So this is your scene. The start point of your scene is the Index.js. And by the way, they use React for creating the front end components. So what we are doing here, when it gets loaded, we add a system, a secular system. It's just a script that rotates the objects that we spawn. Then is here a spawner system, which brings when you click an object, it will spawn a new thing. So we add different systems here. And then in the main entrance function here, we set up a UI. And we create the very first cube with a position. It's a helper class. Let's see, for example, UI, and you see it's it's actually a TSX file, so it's built on. They use actually React syntax for building things. Like you have a UI entity, you have a padding, you have a background. Let me see if it starts now. Yeah, and the cool thing is many things you can just change here directly in the window, and you will see it immediately in the preview. Come on, so cross your fingers. No, seems I don't have luck. Well, no, I just have to wait. Maybe it takes longer. Yeah, okay, it just took longer. So last time I shut it down, I just have to wait a few seconds longer. So, you see here really a preview of your space. You can walk around here. Let's go back to the game area. And what you also see is, by the way, the UI, only when you enter the ground that you own or you're building on, you see the UI. So you can walk and roam to Decentraland, and then somebody enters your space, and it actually turns into a game where you can also earn maybe Polygon mana and things like this. So, and then we have here also some interactions, like here pressing E, and it should spawn a new object. I think that it was randomly, so I spawn a few more here in the UI, and we will see it. It will see that we spawn a lot of objects here around, and they're all rotating. That's coming from the system. And let's change here maybe the size of the UI, just that you see that you can immediately change even things here. So now you see the UI is much larger. So I think that's not too bad. On that, so let me be a little bit too small. And let's have a very short look at systems. This is the secular system that I told you. It queries for all entities which have a mesh renderer. Actually, that example is not so good. Actually, it would better use my custom component cube. That would say works exactly the same way. However, and then it takes from all this, for example, the transform, from all that we filtered, and it gets the transform, and it starts rotating the object. This is why all the objects are rotating. So that's what I told you before a little bit in theory. Yeah, that see, we are coming rather to the end of our time. So this so this was my quick introduction to the potential of Decentraland, and I really hope I could inspire you or give you some ideas what you actually can do and what we will see in the next few years, what will come. So yeah, thank you for watching. Now we can go to the questions.
Christian, hello again. Thank you so much for the talk and for all these insights. And yeah, as you already teased, we got some questions for you. And if you're ready, we can start right away. So the first one would be, are there any challenges or limitations that Decentraland faces in realizing its full potential? How are these being addressed?
Yeah, there are quite some challenges. So let's say in general, you feel also sometimes Decentraland sometimes hangs. I would say it's not always the most stable platform, but this is true for many of the others. When you see the editor, how it's called, where it's the builder. The builder is sometimes hard to use. It's still problems that gas fee and exchanging mana. It's all quite complex. And I think a really big thing still also for the platform is, I think, to be truly a metaverse solution, but there are different opinions about if 2D is enough to be a metaverse. I think a 3D, immersive 3D with virtual reality is important. There are plenty of challenge. Also user adoption, the numbers went also down. Now it goes higher again. I think we could spend a whole hour talking about things that still could be better.
Then we already have also a topic for your next talk. Perfect. So you're very much invited for next time. So but for now, let's go on to the next question, I would say. And maybe you can give us an outlook in the future, because what is the future use case of things like metaverse?
Like what? Like metaverse?
What is the future use case of things like the metaverse?
Yeah. So this is the same question. Let's imagine the question like this: what is the future of the internet when you asked that in the 80s or the 90s? So actually, nobody really know that. It's a dynamic concept. So imagine it as a foundation technology as the internet, and like a foundation technology it changes your social life, it changes your business life, it changes how people learn, how people interact with each other. And yeah, we are very much at the beginning of the journey, and that's why we do that talk, that you get part of the journey and help forming it, because nobody really know how it might look in 5 to 10 years.
Yeah, that's so true. Maybe kind of connected to what you just said, we got another question that kind of relates to that. How can Decentraland enhance access to education and job training? Are there any specific initiatives or projects dedicated to this purpose?
So let's say that there are different platforms with different strengths. So when I would go for that cases, I currently see rather Decentraland as an open world, so it's better suited currently for B2C cases where you interact, let's say, as a new version of a website or something like this. When you want to go more into educational cases for employees, for example, more internal cases. I think the most interesting platform that's just coming up is Microsoft Mesh. There were just yesterday also some announcement on the Microsoft Build that's short before coming. I think we might see it even this year public available. Not officially, but I think there's a good chance that we see it. Then there are other platforms like Spatial.io, which also can serve a little bit like B2C, but you can also use it for internal cases. For cases like this question, I would currently not say that that Decentraland is the best platform. And anyway, I cannot guarantee anyone that Decentraland will be the one that make it, or if it in the end Sandbox, or if it's Spatial. There is a super high dynamic on that market.
Thanks for this answer as well. As you said earlier, it's kind of, when you ask about the future, it's kind of asking people in the 80s, what is the internet gonna be? The person asking that specified his question because now he wants to know, how would you imagine the Decentraland in the future? Any wishes or hopes?
For Decentraland, as I said, so I hope for the immersive client for Decentraland to make it truly immersive, and yeah, and it's also is the question going now more in Decentraland. So I think that would be super great, and other things. We build a lot of experience in let's say in the art area. And Decentraland is also a little bit limited because WebGL technology is a little more limited what you can build. Usually, we love to use shader to make things even much more exciting. And Decentraland has some limitations here. But this is now really narrowed down to the platform Decentraland.
Right. Thanks for this as well. People are really interested in the future because we also got a question, what trends in blockchain do you see or are important to keep an eye on?
So actually, I have to say I'm not an expert for blockchain, so I cannot really tell you what are the current blockchain things that you have to watch out. I see that blockchain is definitely an important enabler for making the connection between different metaverse and identities, but I cannot really tell you which are currently the latest, blockchain smart contract standards or something on frameworks that you have to look out.
Right, thanks. Also, we got a follow-up question to the one where you talked about also other platforms. The question would be, what about the other platforms? Really interested to hear an expert opinion.
Yeah, so you see when you talk about the platforms, you see the currently most attraction has currently Sandbox and Decentraland. Personally, I'm not the biggest fan of Sandbox because I really, we have a big art team and I really like it more art. And so in Decentraland, in Sandbox, you're limited to voxel art, which is very special art. And I think also for real immersiveness later on, it's not so great. So and in Sandbox, you definitely have to use gamification. You have to build a game around. If not, it's completely boring. And you see more people focusing on art and artistical work. They rather go to Decentraland. And then another platform that also has a lot of attraction, and it's maybe Spatial.io. They, as I said, they can also, they have a virtual reality client. They have a web client, what's very convenient. It's not an open world. But you also see more brands, like I think Hugo Boss recently also made an experience there. I think it's one of the highest developed platforms. And when we are coming to enterprise, more company internally, my absolute favorite is Microsoft Mesh, because companies, they have to care about security and data protection and everything. This is even requirements for every certification. And then we have a platform like Mesh. They are built immediately with that in mind, because usually in all the other platforms you could sniff into the packages and the communication, and it's actually a communication technology, and they have to serve the same security like, for example, Microsoft Teams. So currently my two favorites, I would say, is Spatial.io for B2C, or let's say for in an overall mix between B2C and B2B. For just marketing, I think it might be even Decentraland, and for internal cases, for enterprises, it's Mesh.
All right. Thank you for your opinion on that. We got a visionary for our Congress in the comments who wants to know, do you think next year's WeAreDevelopers Congress might be held in Metaverse?
Yeah, that's more a question for you, Benedict. That's a question for you.
Yeah, but maybe you can help us with that.
Yeah, so
I'm no expert in the Metaverse.
I think there is important. So theoretically, it would be possible. So it's a good question, and it's one of the struggles also for a real metaverse. Concurrency is really a problem when you have things like Fortnite. They also even struggle, or have to check that they don't bring too many people in one place because the game might crash. So, and when you have larger events like you saw also in Decentraland with that music festival, they use something you call it in development sharding. So they shard them in bunches of 30 or 50 people, and they all see the same videos and everything, but actually they're in different instances of a room. So that is generally possible. So, and then my personal opinion here is when you do that in 2D and non-immersive, there are cases, we had that even, for example, with Deutsche Telekom, we had a case. And they do a employee onboarding event. It's worldwide, and they use Teams for many tracks where they show different sessions. And people say this is quite good, and you can watch that content very good if you park your avatar in front of a screen and your avatar shows just a video screen from a presentation, or if you watch that in Teams or StreamYard. That doesn't make a big difference. What is interesting is also the after party, and that may be something for VR developers. When you're in a real location, it does not matter. But imagine what the people complained, or I said could be better in the event. They said they have never had the chance to meet new colleagues. They see all the sessions, but they cannot meet colleagues. And even in 2D, you have the concept of spatial audio. You can move around. And when you come to that table, you can talk to that people. And then you don't think it's maybe interesting to talk, you move to the next table and talk with them. So this is something you cannot do in a StreamYard meeting or a Teams meeting. We also cannot do that. We cannot really have a real connection, but we could now later on in an experience like in Spatial I/O, walk around, talk with each other. So I think that is the currently even an added value to conferences. Do it in StreamYard, but maybe do for a worldwide event, do the afterwards a networking party. I think we did it a lot actually last year.
But doesn't, maybe I got this wrong, but doesn't your idea with the instances for the same room restrict the networking part a bit, like with the communication?
Sure, because it's hard to. It's different things. One thing is that the server have to handle so many different connections. You must see everybody needs his own connection for voice audio because spatial audio. When you use a technology like Streamyard or usually Teams, you just you bring it to one stream because you don't have spatial audio. But when you have everyone's spatial audio, you have to have everybody has his own audio stream that cannot be mixed. And then you have all that networking things from all the connection. So it's hard on the server side and it's hard on the client. Try to open up 50 WebSocket connections with audio on a small device. It means boom. And so when it's different things that it limits. And there are other things when you have 100 avatars around you, you also get problems with the GPU because it needs more rendering power. So there is a lot of challenges going on. To make let's say a really metaverse where thousands of people maybe join in parallel.
Okay, yeah, that totally makes sense. All right. Since we drifted away a bit, let's get to another question from the audience. Because you talked earlier about the gamification part, there is someone who wants to know how big is the aspect of gamification in any of these platforms. I still see these things as a gimmick today, although I try to think about real use cases like education, for example, which would make sense for gamification.
Yeah, so as I said, in Sandbox is anyway essential. Without gamification, that platform would be extremely boring. And yeah, people do a lot of treasure hunts there. If you just without gamifications, the environments are mostly a little bit boring when you don't do that. You walk with your avatar around, but there is nothing to interact with. This is a little bit boring. You can also, you can make networking games, team player games. Imagine I had also with a learning company, they told me they do very special trainings where they also simulate things like you fly now to the moon and you only have that 3 items, and then they check the group dynamic, what will happen and things like this. And you can really also play this kind of role games and things like this where they're actually flying to the moon and come into that. You do that training with astronauts, for example, where they can have that, or you can have scenarios where you simulate also a talk between different people. You can have games where people win something. Also very attractive in Decentraland is you have some limited collectibles that you can only collect for a certain time, and then people come to your booth to grab actually that virtual swag. So, but it's also all a little bit in the beginning stage, and that's I think what's interesting is we are on the way on finding out.
Yeah. Interesting times. All right. Since you said earlier the device makes boom when you give too much outers to it, there's one who wants to know. So aren't folks with bad hardware able to join like metaverse gatherings?
Mm-hmm. Yeah. So also one of the problems here. So that's why many platforms and in Decentraland they try to you can also, by the way, adjust the graphic power that you have. Yeah, you can join that. There are things like, for example, a VR chat, which is very famous. I think it's one of the social platforms that there's a lot of creativity on. And you usually need rather gaming hardware for that things. And then you have other platforms like Decentraland, Spatial, and Sandbox. They try to make all the game art more low poly, which is also quite challenging to make it possible for everyone. And I think currently more chance for the platforms to get adoption is to set on the lower level, like like WebGL and Web Ready to get mass adoption. So it's different. Some platforms allow low, others you need game hardware.
Right. Yeah, thanks for this insight as well. Before we run out of time, also to you the question, since you are like the CEO of Hololux, also to you the question, how did you start to become interested in tech and how did you end up where you are now?
So I told a bit from my very early stages. But actually, with the topic of VR, AR, I came up with a friend in co-working. So it's also something I really started my company in co-working. And there was also my friend Thorsten Hari from now the company is called Zeitraum. He's in the marketing area, and they do really cool stuff in even the special effects with CGI and different things, even for clients like I like Bad Robot and things like this. And he told me, hey, while we had lunch there and meet there, I have a good close connection with Microsoft. And when he was in LA, they told him, well, that will be the next big thing that they see in LA. I think it was 7 or 8 years ago. And I said, mixed reality and all that stuff, not so sure. And he said, hey, you have to try that. And then he took me to his office and he gave me the first experience with a DK1. And actually, I would say that was the birth of Hololux. And so we started very, very early. Actually, I didn't expect the journey so long, that the technology now, but also even with HoloLens 1 and DK1, already, I know, 7-8 years on the market. And I expected it would work a little bit faster. And I have currently the feeling it even might take a little longer. But let's see what Apple will do. The hardware would be really an enabler. And there are many people that think maybe Apple make it. Or maybe that they say technology is not ready and Apple cannot make it. But it stays exciting here.
Yep.
So that's how I came to it.
All right. Yeah, thanks for also sharing this with us. And thank you for the interesting talk and also for the Q&A. It was really delightful to have you today. And since we also have your next topic for your next talk, I would say until the next live day.
Thank you for having me. Bye-bye.
Thanks, Christian. Bye.
See you in Decentraland or in the Metaverse. Hopefully.
We will. All right, and we jump right to the last talk of the day, which is held by Somaya, who is lead software developer at Scaling Parrots. But since she couldn't make it today, she pre-recorded us a talk where she tells us about her road to Web3. Let's have a look.
Everyone, my name is Sumaya, and today I want to talk about Web3 and how we can build a Web3 application. So let me introduce myself first. I'm developer lead at Scaling Parrots, that is a little company in the north of Italy that is specialized on blockchain development. I'm a Web3 enthusiast since 2 years ago, and I'm focusing on solving all the blockchain and smart contract issues that's causing on web development. So, Web3, when we think about Web3, we think about so many things because many people are talking about Web3 in different ways and in different areas. So when we think about Web3, we think about NFTs, all these thousand-worthy monkeys that made NFT so popular and so important for the art industry. We think about crypto, all the speculating part that includes investment, trading, all these easy way to become rich. We think about metaverse, all these virtual realities. But actually, I want to talk about the technology that's behind Web3 because this is the important things. This is the good thing about blockchain and Web3, and that we can use to improve all the good thing about the web development. So I want to make a little comparison between Web 2 and Web 3. In particular, I want to talk about centralization and decentralization because in Web 2 we have a centralization. That means there is a central control in our web applications. What this means that is there is a central authority that decide if you have the permission, if you are allowed in the application. For example, let's imagine that we are entering YouTube and we want to upload a video. YouTube will decide if I'm allowed or not to upload this video. And if I'm uploading a video that YouTube is considering not appropriate, they will remove it without giving us a good explanation. And they will not even give you the opportunity to explain yourself, to explain why you are uploading this video. So there is a central authority that will decide if you are allowed to upload or not this video, if your content can be on their website or not. In Web3, we are expecting to have a decentralization. That means that there is no central control that will decide if your content is appropriate or not. So when you want to upload a video or any other type of content, you just have to match the rules of the application that are open to everyone. They can read it. You can read it because all the code is open source. So you can read it, and if your content match these rules, you can just upload your content. And all these rules are made and decided by all the users that access the web applications, and they mainly decide by voting. So it's a collective decision. It's not. So the difference is between a single authority and a collective authority, let's say. And then we have also payments that are so important. It's a big difference because in Web 2, if we want to make a payment, or we want to transfer some money from our wallet to someone else's wallet, we need to use someone else's service. For example, PayPal or Stripe are centralized application made by someone else. So we have to use their service, use their rules to make these transfers. But in Web3, we have payments that are part of the protocol itself. So if we want to make a payment, or if we want to transfer an asset from our wallet to someone else's wallet, we can do it by default because it's already implemented. So we don't have to use a service made by someone else, but it's already included in the protocol. So we can transfer an asset. It's not just financial assets, but any type of asset we can transfer from our wallet to any other wallet that we want. Okay, let's talk about pro and cons of Web3, because we have good things about it, but we have also bad things, and I want to be clear about everything. So we just talked about decentralization, that is a good things about it. We also have ownership, because now we have all the data that is that we upload on the web are we have the ownership on it, because it's not property of a central authority. So when we upload something, it's open on the blockchain. So we have 100% control of our content, and also we have security, because everything it's open, everything is stored in the blockchain, and it cannot be edited or deleted. So everything it's open, it's clear, so it's secure. It's permissionless, because we don't need someone's permission to enter the Web3, because if we have our wallet with our hashed address, we just can enter any Web3 application without the permission of anyone. And interoperability is also important, because it can be accessed by any device and by anyone. The cons, we have scalability. That means that we have some blockchain issues. Blockchain is slow, and this is a big problem, because for performance we need to improve all this communication between the user and the blockchain. We have user adoption. There is a low adoption by users, so it's difficult to have, let's say, a big usability and an improvement of the Web3 application, because there is not enough people using it to try to understand it more. Complexity, because it's not something easy to learn. So at the beginning, it's a little bit hard to learn everything about Web3, but I think that nowadays there are so many documentation and videos and content about it, so it's becoming to be less complex. And there is big issues about environmental impact, because we all know that blockchain it's have some sustainability problems, but I think that with the technology that we have today, we can have the faith that this can be solved in a really short amount of time. I really like this picture because we can see how in pretty much 50 years this was possible. So a big computer become a little shield that can be in our hand. So if that was possible with a really little amount of technology, with the technology that we have today, with all the knowledge that we have today, I think that we can make all these issues about Web3 possible to be solved in a really short amount of time. So let's see some use cases, some real use cases when we can find Web3 application. We have Gamify, so are some gaming application where you can use your wallets, your tokens as an improvement of the classical gaming. So you are playing. They are also called play to earn, because you gain some tokens by playing these games. And everything about the game it's owned by you. So if you buy I don't know some extra on the game, they are actually assets that you can own. So for example, they can be tokens or NFTs that will go in your wallet. So when you quit the game, you have these all these assets in your wallet, you still have it. So if the game shut down, you don't lose what you have earned of what you have bought on the game. Then we have NFT marketplace. There was a big trend about NFTs. It starts shaming now, but the main requests of web applications was NFT marketplaces. So we just made a lot of them. And then we have DeFi. This is the first use case for Web3 applications, because when we think about Web3, the first things that came to our minds are crypto and all these investments and just trading applications, and also all the DeFi. So all the application that allows us to use your tokens to make them grow, let's say. And then we have social media. We don't have the social media like Instagram or Facebook or Twitter. So there is no much users that use them, but it's starting to grow, and they have ownership, they have all the permissionless, they have all the decentralization that we all aim for. So I think that maybe in the future can be more accessible to everyone. So let's talk about Web3 development. So when we think about a web application, we think about this architecture. We have the browser that communicates with a server where we have the front end, the back end, the database, everything inside the server, and we have all the web application built in there. With Web3, it's a little bit different because we have a browser that communicates with the web server, but in the web server, we just have the front end. So we don't have a backend, a database anymore because we don't need it anymore. Because everything we need to access our everything is written in the blockchain. So we just need a way to interact with the blockchain. So we read and write from the blockchain. And we can do that using smart contracts. Smart contracts are just computer programs that automate some operations on the blockchain. So the front end just speaks with the smart contract that will just do their things to the blockchain. Just a read or a write. And so the front end will have to communicate with smart contracts. How we communicate with them? Just using providers. The providers can be providers that we can find directly on the wallet that we connect to access a Web3 application. So when we can use our wallet as a login method, let's say, an authorization method, but also as a way to interact with the blockchain. So we can interact with the blockchain, so read and write from the blockchain using our wallet, or we can read from the blockchain using some open read-only nodes. So we can have public nodes or private nodes from Infura, Alchemy, QuickNode. These are the most famous one, most used, let's say. And they are just like URLs that we can use as providers, and this allows us to read from the blockchain. It's just a read-only one, but are more easy when we want just to read some information without making the user interact connecting their wallet. So let's see what's the developer tools that we need to build a Web3 application. We need some front end, and as front end we can use whatever framework or library we want. So HTML, CSS, and JavaScript are the basics. We need a framework, a JavaScript framework or JavaScript library. The community of Web3 suggests React and use React a lot. But I think that this is just because React is the most easy to learn for non-developers, let's say. So if you are a developer and you know any other framework or library, you can use whatever you want. It's accessible to everything. We need a wallet. I'm using MetaMask because it's the most popular one, and every Web3 user have MetaMask. So if you build a Web3 application, make sure that MetaMask is the first wallet that you implement. And then we need Ethers.js library because it's the main library for Web3 development. You can find so many other libraries, but are just built on top of Ethers.js. So if you learn to use Ethers.js, you can build whatever you want, and it's more easy also to understand what's going on underneath all the services that you can use from other libraries. Then we need smart contracts. As we said, smart contracts are just computer programs that are written in Solidity or Viper or other languages that automate some operations in the blockchain. So there is some code that will be compiled, and we just get these APIs. The APIs are an interface that allows the front-end developers to read all the functions that are written in the smart contract. So every function of the smart contract is translated into an object. So the APIs is an array of objects, and each object is a function of this smart contract. And on each object, you can find the name of the function, so the method name. You can find the inputs, so all the attributes that you need to pass to execute this function, and also the output, so what this function will return. And then we have explorers. In this case, this is Etherscan, that is the explorer for Ethereum. And once you deployed a smart contract, this smart contract is listed into explorers. So if a smart contract is deployed on Ethereum, you can find it on Etherscan, and you have all the code open source open here. You can find all the APIs that you can use on your web application, and you can also try on all the function of the smart contract. You have listed all the read functions, so all the functions that you just can read from the blockchain, and all the functions to write into the blockchain. So you can also try it on maybe to double check what you are doing on your web application, or just to visit the smart contract. And yeah, for this library Ethers.js, just need to install the library. It's an easy npm install Ethers, and you just import it as Ethers. From Ethers.js, we need two classes that are important to pretty much everything you want to do in Web3. There is the provider class that give you access, a read-only access to the blockchain. And then we have the contract class that make you connect to a specific smart contract. So which are the operations that we can do in Web3? We have the wallet interaction. So we need to connect our wallet and read all the information of the wallet. And then we need to read from a smart contract and write from a smart contract to the blockchain. So from the wallet, we need three informations. We need the provider that will allows us to interact with the smart contract. We need the wallet address because it's our signature. It's the only way to recognize ourselves into the blockchain, and the network that we are connected on to match in what network operates the Web3 application and which network we are connected in the wallet. Read and write. When we have ABIs, we need to recognize which function are read and which function are write. So we can see here this state mutability. If there is a view, you can know that is read because you can view an information in the blockchain. If you have payable or not payable, this means that is a write function. Then we have the provider. The provider allows us to interact to the all the smart contracts, so to read information or to write information in the blockchain. So the provider is important, and we can use the provider from our wallet or the public nodes. And the main difference is from the wallet, the provider from the wallet, we can use it to read and write, and the public nodes, we can use them to just for a read-only operation. For example, let's see how we can find our provider from the wallet. In this case, I'm connected with MetaMask, and I can find the provider of MetaMask directly in the window object under Ethereum. It's called Ethereum. So once we have the MetaMask provider that we can find in the window, we need a Web3 provider, so a provider that Ethers can recognize. So we need to translate it into something that Ethers know. So we just need this property from Ethers, providers.web3 providers. There is this method that will transform our provider, the MetaMask provider, into a Web3 provider. Once we have this Web3 provider, we just use this send it request accounts, and we just connect our wallet. We get our wallet address, and then we can read the network that our wallet is connected to with this Web3 provider .get network. If we use a public node is represented into this RPC URL. So it's just a string, a URL string, and to translate it into a Web3 provider, we need this provider class and this method JSON RPC provider, and we pass the RPC URL. And then to make the contract we use this to interact with the smart contract. We use this Ethers class, and we need this method contract. And in this method, we pass the contract address, the APIs, and the provider. So with this contract manager, we can make every we can call every function of the smart contract, and we don't need to care if it's a read or a write. We just need to know which method we have, and we need to pass the arguments that are all the inputs that are listed in the APIs. And we need to care about the provider, because if we are making a read, we can use both the providers, the wallet provider or the public nodes provider. But if we want to make a write, we just need to use the wallet provider. We cannot use the read-only one, because when we do a write, we need to sign this transaction, and also we need to pay some fees to make this operation. So we 100% need our wallet, because we need to be connected to sign or to pay with our asset from the wallet. So this is an example of the read. In this case, we have a read. It's read the name, for example, of a token. We don't need any inputs, so we don't have to pass any arguments. And as an output, we have we are getting a string. And as you can see here, you can use the MetaMask provider, or you can use the public nodes to get this information. On the right, you can see here we have this function that's called transfer. Transfer, we need these inputs, that is the receiver of the amount and the value. This amount, it's a uint 256. That is a big number, so we need to pass a wallet address and a big number, so it's the amount that we want to transfer. And we are getting as an input a boolean, so it's true or false if the transaction will be succeeded or not. And in this case, we just can use the provider from our wallet, because of course we need to sign this transaction. So let's try it out. Let's imagine that we need to build a DApp DeFi that will display our current balance. I'm using Boost for this one, and how we can transfer some Boost from our wallets to any other wallet. Boost is one of the top 5 stable coins, so it's one of the most popular tokens. In this case, the network is Binance, or BNB chain, as it's called now. So first of all, we need to take the provider. We are getting, in this case, this is a borderline case, because in this case I need the information from our wallet, even if we are doing a read, because we are reading our balance. So the balance function, it's a read, but I need to read the balance from my wallet. So I need to know how many Boost I have into my wallet. So to do this read, I actually need my my wallet to be connected, because I need to read some operation from it. So in this case, I'm taking the provider from the window.ethereum, that is the MetaMask provider. I need the signer to sign my operation, but also to get my address. In this case, this is another way to get the user address. Once I have the user address, I can use this information, the signer as a provider, and just make this contract call. This Boost contract is our contract manager using the Boost address and the Boost APIs. In this case, you can see a different way to display the APIs. You can use an array of objects, but also an array of strings, which every string is a function. As you can see, there is the name of the function, the inputs, and the outputs. So I wanted to show you different ways to make the same things. So we have the APIs and the signer as the provider. And this is the contract manager, and we are calling this method that is balance off, because we need the balance of our wallet, so the user address that we can get it from the wallet. And as a response, we get a big number as it is, or we can use these utils from Ethers, that is format units, and we just pass these big numbers and the decimals. It's also an information that's written in the smart contract of the token. We get the decimals, in this case for Boost. For the traditional tokens is 18 decimals is the standard. So we pass 18 and we get the amount as a string. So we can also understand, it's more understandable for humans, let's say. And then we let's see how to make write. In this case, we are using the same contract manager. We just make a transaction. In this case, it's not a read, but is a transaction, because we need to write something. We need to transfer an amount to a receiver. So the name of the method is transfer, the amount that we want to transfer, and the address of the wallet that will receive this amount. And when we do this transaction, we get this pop-up from the wallet that will make you confirm or reject this transaction. You have a recap of the transaction that you want to do. It's a transfer. You have the contract address. You have the amount that you want to transfer. In this case, was 1 Boost. Then you have the data, all the details, and you have also the fees that you are going to pay. So you can, in this case, confirm or reject. If you reject, nothing happens. If you confirm, you will receive this transaction hash, that is the hash of the transaction that have been confirmed. So this console log will appear immediately after you confirm the transaction, but the transaction is not succeeded. You need to wait to get the actual time where the transaction is succeeded or not. It can also fail in this amount of time. It depends on the blockchain and what's going on in the blockchain. But with this transaction.wait, you can have the actual moment when the transaction is confirmed, and in this case, the block in which is confirmed and registered in the blockchain. So yeah, I have a demo for you with this code, so you can try it out and you can find everything on my GitHub. In particular, I have this branch that is called Boost, where I made this particular demo for this DeFi application for this transaction. And yeah, you can find me pretty much everywhere. You can write me. We can discuss about Web3, and you can also give me a feedback about this demo that we just saw. It's little informations, but with this little information and how you can make a read, a write, how you can interact with the wallet, how you can register to a web application. These little things are the basics, and you can actually build wherever Web3 application you want with just this little amount of knowledge, because it's really difficult, but with just little function you can build whatever you want. So thank you very much for your attention, and let's connect and let me know what you think, and if you are building something on Web3, and let's talk about. Thank you very much, and see you in the next time.
Thanks to Sumaya for sharing all these insights with us, and hopefully we see her live on the next day. And yeah, talking about next day, the Web3 day is now officially over, but now is the time to check out the Vienna app if you're based in or near Vienna. It's a very cool startup festival starting next week in Vienna. And while you're at it, also go to worldcongress.dev to get further information on our upcoming World Congress. And since we are increasing ticket prices on Friday, now is the chance to grab also yours. And also thanks to our partners. Scroll down on the live page a bit. We marked all their logos. Those are clickable images. Leave them some love and look at what they are offering. And hopefully we see each other on the next live day, which is on May 31st, when it's all about machine learning. See you then. Bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.